Hello guys, and welcome to this training material for Impact for CAD. So in this material I'm going to go through the written training material we have on our Impact Wiki. I'm just going to do the training. I'm just going to go through it like I was a regular user, and you guys will be able to follow along with me here on the video. So first things first is, where do you actually find the training material? And for that I've gone to Google just to show you guys. And I'm just going to search for the Impact Wiki. I'm going to go in there and I'm going to go down to find the training material itself. We have it right here, Impact for CAD. So here we are, Impact for CAD beginner's course, training course, testing course for those of you guys on trials and so on. So let's just get to it. Let's just go through it. So first of all, we have the introduction here. So I'm just going to read up here and you guys can follow along, listen, read at the same time, whatever you want to do. So this is an extended course of Impact for CAD in version 17 and Impact Reinforcement version 14. Most features and workflows are explained in detail. It is mandatory for you guys to have AutoCAD 2022 or newer, meaning 23, 24, 25 at the time of this recording, or BricsCAD version 24 or 2 or newer. These need to be pre-installed on your computer. There are videos on how you install Impact to run on these ones as well, of course. This video only covers the training itself. So if you don't have this installed, pause the video here, go back, get Impact for AutoCAD or BricsCAD installed, come back here, start the training. So the course we are doing here is carried out using a sample project. This project is provided in the training here under the corresponding chapter when we need it. It's also recommended to be connected to the cloud and training database. The details for this one you will have by the course leader if you're doing a course, or you will get it by email directly if you're utilizing this free trial version we have. So this you will have in your email in that example. For those who are using your own environment, you should get a basic Impact design standard from Strusoft to connect to the standard admin so you can do this. Doing this course doesn't require any prior knowledge of Impact, but it'll be a plus to have some knowledge of CAD systems such as AutoCAD. We are assuming you're already drawing precast elements when you're doing this course, so those things won't be explained, but functions in the software will be explained, of course. In the training material, there's a lot of notes and important notes. These are used to emphasize tips and tricks that will be useful during the training. First important note is the one below. Training uses both text and pictures to explain all the functions and features of Impact Design for CAD. The pictures are equally important to the text, I would say maybe even more important, as they will show exactly where the button is placed, what to click, and what to do. This is done in AutoCAD Architecture 2024 for this course material here. So here we have our table of contents, of course, with different chapters. We don't need to do anything here. We actually just need to click to get started. Now we're ready. So here we come to the overview. These first 2 pages are some background information about Impact. And what I want to do is I want to urge you guys to actually read through this in your own pace, just in the system description of Impact. In this video here, I'm not going to go through this detail by detail, but you can read it. It's just about understanding how Impact is put together. What we want to do in this video and in this training here is we want to get straight to actually drawing some elements and making our projects and so on. So I'm going to click to get started here. First of all, setting up a project. So now we actually start. So let's do that. Download the project file. I'll just click that one. It's going to download for me. while it's downloading, we can just continue on with what it is we need to do. Locate the import option. Okay, open the Impact Project Manager from the Start menu of your computer. I'm going to go down to the Start menu here. I'm going to write Project Manager, Impact Project Manager to open up the Impact Project Manager. And this will open up as our file finishes to download. I can say that if you download these file directly, normally it will just place it in the downloads folder on your computer. Depending on which language you're using Windows on, of course it will be called downloads or Fødsler, as I'm sitting here in Denmark myself, similar. Impact Project Manager is open. I'm just going to minimize it again. The download is finished as well. Then it tells us to go to the import window, click on the three dots to locate and select the project zip file and import the project. I'm going to go through a couple of things more before I do it here, just for the exercise. When you import the project, you're going to get a screen like this. I'm going to show that to you. Confirm the import, open the project after it's been imported and hit import. Other than that, change the project name to something that you could recognize, such as your name or any name that you like. Once we finish importing, we will say no to show log. So I'm going to open the project manager. I'm going to hit import, just as it said, project, source file, and I'm going to downloads, beginner's course, open. You can see it's called BEG_TR. We can call it instead BEG, in my case, _NIK1. I would like to open the project after it's been imported. You will see there's like a yellow exclamation mark here, just that you actually changed the project name from what it's exported from, as Thomas did. So we're going to hit import here. Now Impact will import the project. It's going to take between a few seconds to a couple minutes maybe. We'll let it import. While it's importing, we'll just go back here to see what should we do in the next step. Setting up project properties. In this chapter, as you can see, we're just reviewing them. We're going to do it anyways. There we go. Do not show the log, and please open the project here as well, which we automatically set it to do. So right now the Impact Project Manager has opened the project itself, and what the training material wants us to do now is, and now it says setting project properties. Well, let's call it reviewing the project properties. What we want to do is we want to access the project properties by right-clicking on the project name, and I'm going to show you that. I'm just going to go through here just like I did before first to see what we're going to do. There's explanations about general, walls and slab defaults, slabs, components, reinforcement settings, and so on and so forth. After we go through that, we're going to go to modeling slabs. So just reviewing the project information here. We can go in, we can right-click, project properties, and a window is going to pop up with our project properties. Here we go. We have the general information about the project, such as title, description. You can add in project managers, design managers, direction managers, specifically for the project if you want. There are also some different advanced settings which we're not going to go through at all in this training here, of course. Under walls, you have rotation height of the walls, max mass for double walls, standard gaps for vertical and horizontal joints. Under slabs, you would typically have the support length. Under components, you will have how we normally work when we actually insert the components. So these things are something we want to keep standard normally. Reinforcement We'll go through what need to be standardized as reinforcement and drawings. Well, standard text that come into the actual drawings, as well as what to dimension and how to dimension the drawings. And here you can change that. Again, for this training, we don't touch these settings. We'll do the project as it's meant to. After you finish the training, after you finish the project, you might want to go in here, try to do some changes, see what's going to happen, of course. But we'll just end with an OK without having done any changes here. So I guess that takes care of all the introduction things here. We have imported our project. We've gone through the introduction. Now we're just going to jump to actually modeling slabs. And that's where we're going to start in this training. So modeling slabs, first of all, we're going to go into the building and floor settings. This is again just for an overview. Just as we did with going into the project, we're going to click model, we're going to right click, hit buildings and floors. Here's an explanation of it, and I'm just going to explain it to you instead. We're going to go into model, we're going to go to buildings and floors, and in here you can see we have 4 floors in this building. There is one building. You want to create a new floor, you hit plus, you right click, click new or duplicate. We have A, which is the finished floor or the bottom of the element if you'd like. You could also use F for that. We have C, which is floor to floor. D, which is top windowsill, for example. E, which could be bottom of the slabs. And we have crane time, which is some extra time for cranes. But basically, what you want to do is create new or delete floors, create new buildings, and so on. And it's very simple to do that here. So of course, when we're going to start to draw the slabs, it's going to assume to begin to draw them in the elevation 2400. There we go. So let's get back to it. Finally now, as it says, it is finally time to start creating elements in Impact. Thank God. That's what we came here for, of course. But just before that, we'll need to activate the connection between Impact and our CAD software. In order to do that, we follow the process below. Basically, we open a drawing from Impact. Super simple. The important note here is you can't just open AutoCAD or BricsCAD from your desktop. You need to open it from within Impact, meaning that all the modules, the database connection, everything that makes Impact go round is activated when you open an Impact drawing from within the Impact Project Manager. So what we're going to do here is we're going to go under Floor Plans, Drawings, Floor Plans, and open General Arrangement 0101. And then it should look like this. So let's try and do that. Drawings, Floor Plan, General Arrangement 0101, open. You can also double click. So now in my case here, it's going to open AutoCAD Architecture 2024 for you, 2025, 2026 if you're doing this next year, and so on and so forth. If you're doing it a couple of years from now or 3, maybe we've done a new training material, but you get my drift. It could be 23 as well. So let's just let it open AutoCAD here. Now when it's open AutoCAD, and if you've just installed Impact, you might have some more windows and things like that here. Some small tools for reinforcement and so on. Well, basically you can just turn them off. We're only going to use the Impact menus at the top here during the training. But you can see my background is dark gray, but otherwise it looks exactly like the picture here. Note, the menu in CAD that will be active on the top is called Plan and will be used to draw all elements on the floor plan, which is the menu right here. So this has nothing to do with AutoCAD and everything to do with Impact, of course. So now we're almost getting ready. Drawing slabs by area. So you can see there's a few different areas here. Can almost look a little bit complex when you look at it like this, but it's quite simple. Areas A, B, C, D, and E. And I can already tell you now, well, basically we're just going to draw the left half. And then we used a command called mirror to have impact draw the right. So we're only going to have to draw half of this. And it's going to be fast. So brace yourself when we go into it, of course. I'm going to go through it slow, but it's still going to go fast. So to draw Hollowcore slabs, you need to go into Precast Plan, Hollowcore, Draw, Hollowcore. In the General tab, select Section and Strand Patterns as needed, then proceed with Endcaps and Model tabs for additional settings. So here, there's a couple of screenshots where we'll just leave it as below. And I'm going to show you when I get into there. And then we simply hit OK, and then we're ready to draw it. So let's go in and do this. First of all, I'm going to Plan, Hollowcore, Draw Hollowcore. And it's going to pop up here with the section 19. Here you will have all your different companies' sections, different Hollowcores. In the training, we use the one called 19. We don't do any changes. Endcaps, you can control the edges of the elements if there are holes and so on, used to mount some reinforcement in on the side. We're going to change these things later, so no worries. And model that, for example, controls the elevation and so on. And you can actually see the elevation is 2445 here in this case, which is the 2400 plus 45 in this case at least. If we hit OK, Impact is asking us a question now. So you can see next to my mouse cursor it says specify polyline or, and if we read at the bottom tab, it says specify polyline or internal points or windows. So let's see here. Select window and proceed to draw the slabs in area A. Note, the window function is basically a rectangle that we need to create in order to define the area of the slabs. It is commonly used by most of the impact experts. So using this to begin with, you're almost an expert. Specify the top left corner and close at the bottom right corner. Press enter or right mouse click. Then a support length command will show. Basically what we're going to do is we're going to give it 80 mils on the top and the bottom. Let's call this the top, let's call this the bottom, and 0 for the sides. Then the software, I'm just going to go through it just like I did before, and then I'm going to take you guys through it. Then the software will ask us to move the base point if we want. We can keep our base point here, but what we want to make sure is that this large recess here, which is going to cut a full slab, is of course only cutting in one slab, because this will make no sense. It will allow us to actually move the cut element, and we can move it to the side, for example here, 1 point in, depending on how you work in your factory. In the training material you can see it's getting moved to the outside here. Here is a GIF that summarizes the whole process. We don't need to watch that GIF, I'm going to show you instead. So here, specify polyline, no, I'm going to do W. As you can see in the bottom, you can click on it as well. W for window. Top left corner, I'm just going to zoom in, snap it here. I'm going to zoom out, snap it to the bottom right corner. There we go. Support length, you can see it lights up green. 80, 0 to the side, 80 to the bottom, 0 to the side here again. No slope. And then you can see we get the exact same picture as in the training. We're going to leave the insertion point here, so I'm hitting enter again. Now we want to move the cut slab. The cut slab, of course, as you can see, is the one that shows a picture of a cut slab as well as a sister on it. We can hit next, next. Now you can see everything lines up. We can keep it here to the side, or we can move it one in. Because in the training we're keeping it here to the side, I will do that as well. Right now I'm moving with the arrow buttons on my keyboard. You can also use the mouse and click. I'm going to move with the arrow button down to apply, and I'm going to hit enter. That's it. We've actually now got a whole floor of Hollowcore. One which is cut, even the side where it's cut as well. Let's go in and jump on to the next part of the exercise here. The next part is drawing balconies on area E. So in order to help you define the area, we've already created two closed polylines for the left side balconies, which will be used as a guide to draw the balcony slabs. Let's just go in and check here. You can see here's a polyline and a polyline. Basically, otherwise you can draw any polyline and shape you want to. As long as it's a closed polyline, Impact will be able to use this. The exercise here in Impact is not about how to draw polylines in AutoCAD, so we've created this already for you. Find now precast plan slab and draw a slab. The following window will pop up. Select definition SS19. Review the lift and model tabs, but don't change anything. Press OK. So we will go in here. We will go to slab. We'll go to draw slab. SS19. Just going to check lift side and model. The same thing almost as the Hollowcore, just here we have some different in the lifters. And what did it say? Hit OK, of course. Press OK. Then select single. Then specify the polyline. In the slab segment properties, set the Endcaps to none and support length for 0 on all of the sides. Copy to all and then apply. Do not erase the polyline. In the end, the slab should look like this. Also, please do the same procedure for the next slab next to it. Okay, so we're going to do all of this now. Going to hit OK. We're going to do single. We're going to specify the polyline. We're going to set the end cap to none. Support length to 0. And I will click copy to all. You can see the end caps disappear. And I'm going to hit apply. Erase polyline. What did he say? No. And there we go. Now the slab looks like we want it to look. 4 lifters, a slab with no name. Please do the same as well for this one. Then we're going to hit draw slab, going to hit OK, going to do single, specify the polyline, no end cap, copy to all, apply. Erase, polyline, no. Here we go. We have the second slab as well. So now actually we have Hollowcores and slabs. And if I go into the south isometric view, southwest, for example, you can see these are actually in 3D presented in an elevation. They're actually also detailed right now, but later in the course we'll get into this, how to show the actual detail. Right now we are in the sketching and the wireframe because this is much faster and this is where we would normally work in Impact. It's all about speed and precision here. So that's it. That takes us to the next slab. So if you remember me saying before, this is going to be fast. We've already drawn a Hollowcore. We've already drawn 2 balconies. Now we're going to draw some pre-stressed slabs. Again, really simple now. We've gotten used to it. We'll find precast plan slab, but now we're going to do pre-stressed slab instead. If the properties are not like shown below, we'll adjust them. And then we'll hit OK. And this time, we will use the command window again. I'm just going to go in there, go until OK. We're going to go back here again, just so it's not too much. Slab. Now not draw slab anymore, but draw pre-stressed slab. Here we go. We have the pre-stressed slab. Everything looks like it should. Reinforcement template, DA001. So you can see this one said nothing. We would like it to be DA001 as in the picture here. We're going to hit OK. Now it asks us polyline again or window. We're going to do W for window. Going to go back. We're going to see good. We use the window command. That means top left to bottom right. Once you've selected the area, you'll get the options to add end caps again. Use end cap DD19 3001. Press copy to all. Use support length 80 for the top and bottom and 0 for the sides. Here it's the screenshot for it, and then press none to the slope, and then move the cut slab to the actual right end to have the slabs look like the following picture. Good. Let's try that then. Top left to bottom right. Zoom out a little bit here. Support length, the green one is 80, that's fine. 3001. We will use that. And we can even copy to all. Now the thing is that we will have support length on the side, so I'm just going to do 0. Next. 80. Next. 0. And then we'll hit apply. Specify slope, no. Insertion point is fine, but what we wanted to do is move the cut slab to here, as specified in the training material. We'll hit apply. Here we go. So you can see with the writing here, the small red writing, we have our end caps. As you can see here at the bottom, the sides, we have the slabs, we have the lifters. The small narrow slab will have diagonal lifters and 2 lifters in this case, because that is how it is specified. The other ones will have 4 lifters. If you noticed also in our Hollowcore, we didn't have lifters. That's because maybe we're lifting with clamps in this case, but I'm pretty sure that later there will be an exercise of how to actually configure lifters as well in Hollowcore if you need that. So now we have pre-stressed slabs, we have slabs used as balconies, and we have Hollowcore. Let's go to the next one. Now we're going to draw some double T slabs. And for a building like this, we're not going to need double T slabs, for example, for a room like this. But for the sake of the exercise, we're going to take you guys through it, of course. So for area C, use the command draw Hollowcore to draw the double T slabs by changing the section to match the double T specification. Go to draw Hollowcore, select the section DT2400 120, review the end cap and model tabs, and press OK. Here, we will use the command points in order to pick up the edges of the area that we want to draw a double T. The highlighted corners are the places to snap our points. So basically, there, 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 and there. The support length should follow the picture below. 80, 80, 80, 0, 0, 0. And none to slope. Now they should look like the following picture. We keep the cut slab in the middle. So let's try this. We'll go here. We will go to Hollowcore. We'll go to Draw Hollowcore. But now we're going to select a different profile. We're going to select DT2400 120. You can review the end caps and model tab again, as it suggests. We'll hit OK. We will, instead of actually selecting making a window now, which it thinks we're going to do, is we're going to specify first corner point, no, or points. I'm going to select points, and then I'm going to add the points that it said here, 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 and here. And then we can do next point or close. C with close, or just press enter. As you can see, it's already selected. So we'll hit enter. Support length, it lights up green here. That's where we want 80. We'll hit enter. Here we want 0, enter, 80, enter, 0, enter, 80, enter, 0, enter. So now you can see here again that, well, the cut slab is in the middle, just as suggested in the actual material. So that's what we're going to keep. So I'm just simply going to hit enter here. We'll keep it in there apply, enter again. Here we have it. So let's go back. So basically now, Hollowcore, slabs as balconies, pre-stressed slabs, and double T's. Should look like the following picture. Great, it looks like the following picture. All good. Now for the last slab already. Area D. Precast plan, slab, draw slab, select section SS19, use the window method to define boundaries. Support length 80 for top and bottom, 0 for left and right sides, Endcap 101 for left and right sides, and 301 for top and bottom. The slab should look like the following. Then our whole half floor should look like the following picture. So now if you can feel, I did it a little bit faster, but that's because by now you should know the drill, if you can say it like that. Let's go in here. Let's zoom in to where we want to draw the slab. Draw slab, SS19. Okay. We're going to do single. We're going to do W for window. We're going to select top left, bottom right in this case again. And in a case where, as you can see here, I've zoomed in. You can zoom out, you can't move, but you can zoom in and out. So here we want the support length to be 80, 301. We're going to step to next. We're going to be 0. We're going to do 101. We're going to step to next. We're going to do 80, 301. Next, 0, 101. Apply. No slope, of course. Here we go. Now we have our small slab as well. We're going to zoom out. We're going to check if our floor looks like it should. And it definitely does. Now we have half of the building here. Now we're going to get ready for the next part of the exercise. So the next thing we need to do is draw some recesses. Draw slab recesses, chapter 4.3. So first we need to define the recess locations. From the drawing it's clear that we have recesses in the following places, as shown in the picture below. Here, 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 as well as this one. But it does say, skip the large cutout on area A. This will be added later as a hanger detail on the Hollowcore. Okay. So find and use the command precast plan components, recess, draw, recess, filling. That's a long one here. I'm just going to go in and show you where it is, and then I'm going to go back to this one again. So we have it right here. Components, recess, draw, recess, filling. I might as well just click it. Now it asks select element or none. So what are we supposed to do in the training? Because we can do both here, of course. We're going to see select none on the command line and then click on the slab in the following question that comes. The dialog box pops up. Select either circle or rectangle. We'll select rectangle. Check cut reinforcement if we want the reinforcement to be cut. And press OK. Then we can draw the recesses as following. Remember to draw diagonally when drawing the recess. Press enter when finishing both of those. So these two recesses first. Once we've done that, then we need to add them into the elements. So let's do that later. Let's first actually draw them. So select none here. Select slab, rectangular, cutout, cut reinforcement mesh. OK. First corner, second corner. We'll do as we did the last time when we drew the slabs. One recess here, another here. We'll hit enter to finish it. That's actually what we needed to do. So let's get back to this one again. The recesses are drawn but not added to the elements. You can see that because they're purple. We need to add them to the elements. So what we're going to do is we're going to go to Slab, Edit, or double click on the slab and then Add. After that, we need to say yes to update the lifters if it asks us. And then press Exit to save it. I'm going to show you that as well. And they've saved. After that, we'll need to make the column recess gaps. So let's go to that after. So let's go in here. First of all, I'll double click this one. Add. All. Exit. There we go. It's cut. For this one, we can go into Slab or Hollowcore and hit the Edit button. We'll edit. We will add all. Update lift. Yes. Exit. Here we go. This is cut as well. Very easy, very straightforward. So the column recess gaps will perform the same procedure as above and create smaller rectangles, it says, rectangles, it should say, around the edges of the column. We will then add first the Hollowcore and then the pre-stressed slabs. It should look like the following picture. Okay, let's go in and draw it. We have the column and we actually have some overlap for the Hollowcore and the slab. What we're going to do is we're going to draw recess. We're going to say N, none. Don't select an element. Type slab. Rectangular top cutout. We're going to draw it. There we go. And we're going to draw this one. So this is where we are later going to draw a column. Then we need to add it to the Hollowcores and to the slabs. And here I can show you something. We can do like this. Select both Hollowcore, then edit, and then add and exit. As you can see now, it cut both of them at the same time. Now we can do the same thing here for these two at the same time. We can also just double click as we did before. We're going to edit, add, update all, exit. So there we go. Now it's cut out in this one, it's cut out in this one as well. The recess here, we don't need this one anymore, so we can actually remove it. So that step is done as well. Next, we come into mirror slabs for symmetry. And now that we've finished drawing the left side of the slabs, we can save times and mirror this side to the other. The building is on purpose made symmetrical so we can explore as many options as possible during the beginner's course. Select all the slabs in the software. Once selected, find and use the command precast plan slab mirror slab. Mirror all the slabs from A, E to F to I. We'll use the building's center line as a reference. The first point should be the middle of the model. The second point should be on the same vertical line anywhere. We don't want to remove the originals. And then the floor should look on as the following here, which is great. So let's try all that. I'll go in, I'll select it all. Since we're mirroring elements, I can simply go in and do like this. I've selected more than the elements, but that doesn't really matter. I'll go to plan. I'll go to mirror slab. I'll select the building center line. In this case, which is also here. And then I just need to go up or down, just on this same vertical line here. Remove originals, nope. That's it. Just gonna go out here. Look at that. We got a whole floor of slabs now. So now what it asks us, I think, is to draw the recesses here as well. Add recesses on the right side. Draw additional recesses unique to the right side using precast plan components, recess, draw recesses. We have 2 rectangulars and 1 circular. Add them the exact same way as described in the section above. Then it should look like this. So let's do that. Here we go, and we will go in and we will draw recess, no element. For slab, I will try here and just draw this as 1. It will cut into 2 elements, of course. Now I can give you like an expert tip. So to change the type of recess we're putting in, instead of going to the command again, I'm just going to hit enter once to finish the command and enter again to start the command. Then I can go no element, slab, and circle instead. And we will go here. Says specify a center point and the diameter. So what is not described is, of course, we need to add it again, just as you remembered you did. So now the course is starting to expect for you to remember things, and if you don't, you can always go back and look at it again. Slabs, we can edit all 3 at the same time, add, exit. So now we can see here, these are nicely cut, all of them. Perfect. So now we come to modify the elements a little bit. In order to modify our slabs, we need to select them. Select all Hollowcores in area A and F. Find and use precast plan Hollowcore, edit Hollowcore, and go to properties. Then we're going to change the strand pattern to 6. Great, we'll do that. So let's select all of them. Again, when selecting, you can simply do like this. We can go into edit Hollowcore, properties, general, strand pattern, 6. Look at the picture above right now. We have 4 strands. Now we have 6. Press OK. And end with exit. Very important to end with exit. That was it. We changed the strand pattern in all the Hollowcores on the floor. Easy. Now, for the Hollowcores, we want to manually add lifts. So we'll go to the insert lift option. And in this case, we have some cut Hollowcore. So we can actually run it twice if we want to. Maybe we'll do that. Follow the information shown in the picture below. Press OK. Lift add necessary lifting anchors necessary for transporting the elements. If you're not using lifting anchors for your slabs, then you can skip this step. Well, we'll do it anyways, even if we don't use it. So we'll first take all the ones that are not cut. Expert pro tip again. Go to plan. We'll go to insert lift. Here we suggest where to put them. Please dimension on the shop drawing as well. Add a core filling. Lifters in our Hollowcores. The cut slabs, let's go in again here. Add the lifters. And now we suggest different placement because, of course, they're cut. This is fine. We'll hit OK as well. You can even have it add lifters automatically, or it will add diagonal lifters if the Hollowcore are more narrow, and so on and so forth. As you can see here, it says automatically impact will add a core filling around each lift to reinforce the slab structure. You can also turn that off if you want to, of course. Now the next thing is adding core fillings. So a very specific job that needs to be done. We have a Hollowcore with a rectangular cutout in the middle, and we might want to add core fillings here. So how to draw a core filling is, first we find and use the command draw core filling, we mark the area requiring our fillings, such as this short side of the slab or near cutout. We're going to edit this as needed so we get it as we want to. For example, remove the unnecessary cores. We only need, in this case, core 3 and core 6 and maybe 1200 millimeters. And then the slab should look somewhat like the following. So let's try that. We will go in on Hollowcore, draw core filling, select the Hollowcore, this one, first corner point, second corner point. We only need 3 and 6, so we can actually delete, 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 delete. You can also draw it more precisely if you want to. But again, this is completely up to how you want to do it. This is what the training material suggests. 3 and 6, and OK. There we go. Now we have our core fillings. Next thing here is going into hanger details. So now we want to find and use the command precast plan, Hollowcore, hangers. As you can see, it's the same place with Hollowcore as everything else. Set the hanger support length, set the support length to 380 millimeters and the hanger width to 100 millimeters. So we're going to go a little bit back and forth here because it's very specific. We're going to go to hangers. I'm going to go to this one, edit. I'm going to go to hanger 380 width 100. 380 width 100. We have that right here. This is already configured, so press O and K and OK to leave the hangers menu. That's fine then. OK and OK. So now what we want to do is create a custom hanger detail. Define hanger and plate setup. Find and use precast plan Hollowcore hanger details to combine the hanger and cast and plate details. We're going to make a new one, call it HCS 19 hanger detail HC 185 millimeters. Let's go here, hanger details, new, HCS 19 hanger detail 185 millimeter. Right, OK. Get to the next window. We're going to give it 30 millimeters from edge using hanger 0407 and adding welding plate 0341. I'm going to go back and forth a little bit because I don't think my screen is big enough to have both on the screen at the same time. 30 millimeters. Here we have a lot. 03, now I forget it already, 41. There we go. 2 cores from the edge. Great. We'll put a recess at top, 300 by 400, countersink by 10. By 400. Recess at the top. And then we can also select if we want some core fillings. We want 2 core fillings with a length of 600 millimeters. The countersinking of the welding plate should be 10 millimeters also. 10, 2, 600. We'll set them as visible, I think, as well. Great. Press OK and OK again. OK and OK. Drawing the hanger details. We'll apply the hanger detail by selecting Precast Plan Hollowcore Draw Hanger Details. And we need to place it as it asks us. This is the slab we need to support. These are the slabs supporting it. This is the first and second corner point. We'll select the hanger detail we just created and press OK. And then after following the steps, it should look like the following. So let's see about that here. We'll go here to this one. We will go in and we will draw a hanger detail. This is the one we need to support, and now we'll hit enter. This is the one that should support it, and this one, I'll hit enter again. First corner point from here to here. We'll select the detail we just created, hit OK. There we go. Now we'll have it. Perfect. We'll go back to the material, and now Impact will ask us to actually save the slabs, save the elements. So we want to save all of the slabs. Hollowcores as HC100, double T's as DT100, pre-stressed solid slabs as PS100, solid slabs as S100, and balconies as E100. Go to precast plan slab, save slab to save the slabs. If you select multiple element types at once, the following prompt will show. For the sake of this training, it is recommended to select the types one by one. Start with area A and F and start naming our elements Hollowcore 100. After writing this, press enter or right click. The Hollowcore should look as the following picture. The element marks does not have to be the exact same. Don't worry. Depends on how you actually select them. That's not important for the training here. The most important thing is to have the names and element IDs created on your slabs. Create this, continue with the rest of the elements, and follow the naming proposed above. The whole floor should now look like the following. Okay, let's do that then. We'll go here. We'll select all the Hollowcore. Go to Plan. We'll go to Save Hollowcore. We're going to propose to start with HC100, then simply hit enter. Now Impact is going to save them all, give them all numbers, match them all if they're the same, give them new numbers if they're not the same. So there we go. These are saved. Let's go ahead with the balconies. Select all 4 balconies. Save slab. E100, I think the balconies were. So let's save them. Those are saved. We will select the pre-stressed slabs. And we will save them as well. PS1, we'll say 100. Now these will also be saved again. And now we just have the double T's and the small regular slabs. So first maybe the small slabs. Save. E104, that shouldn't be it. What did the slabs say? S100 maybe. The reason because this is the same type as the balconies. So let's just check up here. Solid slabs S100. Let's do that. Even if we call it something else, it's not that important. This is, this is a training material. So you save it as you normally save it in your company when you're using it anyways. Then the double T's, and then everything is saved to the Impact database. Saving this is the biggest, most important step in this process here, because once they're saved, we can actually create the automatic production drawings. And that is a huge step. It's ready to create production drawings now. We have a section in the training for shop drawings and production drawings. We're going to get to it. But first, we want to finish modeling our building here. So we're going to go to walls. We're going to go to solid walls, sandwich walls, columns and beams first as well. And we're even going to make some stairs also. Great. Let's move back to the Impact Project Manager and reload and then zoom to fit on the model view. Then the element should look like the following picture in the model view. let's go in here, go to the model view, and reload the model. It's going to take a few seconds. It's processing data right now. But then we should have a project management / planning model. This model, for example, you'll be able to plan in impact production later on. We're going to zoom to fit. It looks exactly like the picture that we have in the training. The difference is I have a little bit of a different view here. I'm going to go in here and I'm going to turn these planning tabs off. There we go. So now we only have impact design. Great. Well, it looks exactly like that. I just have a different graphic setting on. Graphic settings of the Impact Project Manager, maybe not so important for this training here. Go back, say that is perfect. So that is it. We finished our whole floor, our balconies, our slabs, our double T's, our Hollowcore, everything is done. Now we're ready to start modeling walls. So the first chapter of this one is modeling walls in elevation view. So what we want to do as the very first thing is we want to go in, find the elevation drawing that's prepared for the course material and open it. If there's no elevation drawing, you can create one, of course, but in this material we've created some for you just to make it easy for you to learn how to use the software. In the Project Manager, expand the Drawings node, double-click on Elevations, and select the drawing label GAE01N. This elevation drawing has the architectural reference level 1 north elevation attached for guidance. So let's go ahead and do that. We'll go to Drawings, Elevations, double-click. This one, double-click or right-click and open. You notice this one opened immediately because we already had AutoCAD opened. Access the drawing settings. With the drawing open, navigate to Precast Elevation Settings to set up drawing parameters. We want to switch on Element ID and Elevation Line. Okay, let's go ahead and do that. Drawing settings here. The bottom left one with the wrench on it, Element ID and Elevation Line. Here you can also put in other things on the element so you can actually see that as well, of course. We'll hit OK. That's what we're supposed to do here. Now we want to actually create the walls and set some boundaries. The first thing is specifying wall boundaries. Before we start drawing our walls, we want to specify a predefined area. In order to do that, we'll draw a boundary rectangle around the walls of the first floor. We will use the command rectangle in AutoCAD, and we will draw a rectangle that covers the wall as shown in the picture below. Okay, let's do that then. How to use the command rectangle. Command is called rectang actually, so let's use that. We'll draw them. From, let's say, do we start from the bottom or the top here? What is actually in the sketch? From the bottom of that one to the bottom here. That is fine. That's what we'll do then. Rectangle. From the bottom here and to over here. That's it. We drew it. We have a white rectangle here. Now we want to find the command Precast Elevation Walls Draw Wall. Select the type Sandwich. And in the Endcaps dialog here, we want to go with WD 340 millimeters. And for the bottom, WD 34 830, for the sides 804, for the top 831. Okay, let's go in here. Draw. wall, sandwich wall, select polyline. There we go. Type WD340 for the top, 831. Step to next. 804 for the side. Step to next. 830 for the bottom. Step to next. Was the bottom 830? I think it was. We'll double check. 804 for the other side. Let's just double check here. 830 for the bottom, 831 for the top, 804 for the sides. That's how we want to do it in the training material. Note about pressing step to next or step to previous that you saw me doing already. So I think that's covered. So that's it. We're going to press OK. And now the wall properties will pop up here. So in the General tab, there isn't any need for any modifications. But there you can adjust the panel thickness, the materials, the reinforcement templates, cast type, and production line if needed. We'll go in and we'll just have a quick look at that one. So that is it as it is. All good. And then the lift and bracing tabs, no need for any modifications. Maybe I don't need to go back into the CAD to see the same window. But there we can set parameters for lifts based on weights, specify if the wall requires different types of setups there. Endcaps, additional top or bottom end caps if needed. We already configured it before. Custom material recipes. This is where we can add some what we call recipes for the custom materials. We don't add anything in this definition either. And in the model tab, here we can specify the model views and rotation preferences. Very important here is to unmark the box for elevation is up in mold. Okay, let's go in and check that one. Model. We don't want the elevation to be up in mold. Basically because the inner panel is up and we want to be looking at the outer panel here on the elevation. We're looking at from the front of the building or whatever we call it. That's fine. Press OK, press no to erasing the polyline. The wall should look like the following picture. Great. We'll hit OK. And then we're ready to add openings. Add openings. Draw openings based on reference. Find and use precast elevation opening. Draw opening. Draw openings according to the architectural reference in the drawing. So that is what we will do. Use the properties as shown in the following window. Ensure each opening matches the label in the architectural drawing. Press OK and then place the window in the corresponding positions. The window endpoint is the bottom left corner. You can add multiple of the same windows and doors at once. Press Enter when you place the last window on position. Repeat the command, draw openings, and add all of the windows. The final result should look like the following picture. Okay, so let's do that. And we didn't finish the other command before. We just did that now. So now we will draw opening. We can select the element here. And then we can see F14B, that's this one. I'll hit F14B. Press OK. Bottom left, there we go. Bottom left. And over here as well, bottom left and bottom left. Then we hit Enter to finish the command. And the trick here is you don't have to click openings again. You can actually hit enter again. Then select element. And now we're going to do F3. F3. Okay. There we go. Just getting it to snap in the bottom left corner here. And then hit enter and enter again. Then select F1, of course. Select the element, F1, and OK. We're going to select this one as well as this one. I think we've got it all. So let's check against the picture that we had. Does it actually look like that? Final result should look like the following picture. It does. Note, if some are not added to the definition, meaning that they're like purple or green or something, then you can do exactly like we did before with the slabs, double click and hit add. And I can show you how to do it, but they are all added though. Double click and add. All exit. That's basically how you do it. That's what it says here. The next stop is for us to split the walls. Before we go to that, if you look at the screenshots and you look at your own model, it might look a little bit different. For example, the name here, it might have an arrow on it. So if it has an arrow on it, it's basically because of the view we look at the wall from as standard. And if that one is flipped. In this case, what we did before makes it flipped because we're looking at the elements from the outside of the actual building. And we're not looking at the elements how they're looking at them in the production hall. So that's actually why it puts the arrow here. So don't have to pay any mind to this. Just follow along with the training and everything's going to be exactly as it's intended. So splitting walls vertically. Using the command precast elevation walls split wall vertical. We'll use that in order to split the walls into smaller pieces according to this XREF. Select the wall you want to split and then right click on the mouse. Select the gap between the splits, 20 mil, and then right click on the mouse or hit enter. Select the end cap, 804, and press OK. Select the midpoint between the splits. There's a little bit of a line we can use to snap on. And enter. Once we split all the walls where we need to split them, the result should look like the following. Good. Let's do that then. So we're going to go to walls. We're going to go to split wall vertical. We're going to select the wall, hit enter or right click on the mouse. Gap 20 millimeters, it's stated. End cap 804. And OK. And we'll zoom in and select the midpoint between the walls. There we go. There's a little line there for us. Here we go as well. Here we go as well. Here and there. And then the last one is this one. We will hit enter. And now Impact is splitting the large big wall that we had now into pieces, which are actually our precast walls. So there we go. Now we have everything in pieces. Looks perfect here. Great. So let's go on to this one. Now what we're going to do is connect with some welding plates. And all of the ones that has this detail below them called AD06 00804. Those are the ones we want to connect. So 1, 2, 3, 4. The ones in the middle are going to be connected with solid walls later on from our actual 3D model and plan drawing. So we're not going to do anything there right now. Finally, use the command precast elevation walls connect walls. Select the first 2 walls from the left side and press enter or right click on the mouse. Find the joint and press OK. Then we will get this pop-up where we can use to specify the placement. Just review it and press OK. And then what is the origin point? And then we select the same origin point again. In the following window, press OK to place it. And then the connection should look like the following. We need to do that for all of these. So let's try and do that also. So we're going here. We will go in and we will do connect walls. Select walls, these two. Select this specification 00804. Hit OK. Now again, it will put in two, each one 600 millimeter from the bottom, the other one 400 millimeter from the top. Hit OK. The origin point should be in the middle. And here we hit OK. Zoom out a little bit. Now we can see it's adding these welding plates. Select walls here again. Specify origin. It added them. Select walls again. If you get out of the command, just rerun the command again, of course. But it should stay in the command as long as we're doing the same connection on the walls. Select walls here. Enter origin point. There we go. And then we can finish the command with hitting enter. Again. Elevation lines. So now we want to create an elevation line that is used to connect the walls and the elevations into the 3D model. So we're going to create an elevation line by opening precast elevation, elevation lines, and selecting new to create the elevation line. We're going to pick the reference point, which is 1 and 2 in this case here. Once that is picked, it should look somewhat like the following. Then move the elevation line symbol to the left of the drawing and click OK. Confirm its placement. OK and OK. So let's try again also and do that. Elevation lines, here is the one. New. What did we call that one? Did we call it N? Let's just go in and double check. N, elevation facing north. Facing north. Pick reference point. There we go. And then the second one, here we go. And as we could see in the material, we write in the elevation reference point 15 in this case. That's because we had the floor to be 15 in the floor settings earlier. So that's it. We'll hit OK. And press OK one last time, it also says. We'll do that as well. OK. There we get it. And let's see what we need to do now. So attaching the walls to the elevation line. Select the precast elevation edit wall or double click. We're going to do edit wall because we need to select them all. Select all the walls and select properties. Go to the model tab and select elevation line N. Press OK when done and then exit. So let's do this as well. We'll select all of the walls. Plan. Once all of them are selected, we will go to edit wall. Not on plan, sorry, on elevation. We'll go to edit wall. So if you can't get it to work here, it's because you did the same as me. Model, elevation line N, and hit OK. We'll hit exit afterwards. Now, It is time to save the walls. So just as we did with the slabs, we'll select them, we'll hit the save button, and we will do SW100. Select the walls, and go to elevation, save, SW100. Here we go. And that actually concludes our work here on the elevation drawing. So congratulations on that. You know now how to make walls on the elevation drawing and even how to map them to be put on the 3D model or plan drawing afterwards, which we just did now. We mapped them to an elevation line. So actually getting them in on the floor plan, we'll do that as well. So return to the floor plan drawing, reopen the floor plan in the project manager. So I already have it open here, but just for the sake of the exercise, I will save this drawing here, close it, and go in and reopen it. Drawings, floor plans, GA0101, open. So there we have it again. So there we have it again. Specify the elevation line in the floor plan. Go to precast plan, elevation line, and edit the reference point for the elevation line, choosing the upper outer right corner to set the orientation in the floor plan. Then pick the reference point and rotation of the elevation line. Since it's north elevation, we've previously picked the lower left corner. The elevation view of the walls is the front of the wall, and we have inner panel up. Then that's why the reference point needs to be the upper outer right corner. So let's press OK. So let's do this part here. We'll go up here. We will hit elevation lines in the plan. We'll take this one, we'll edit it. We'll pick the reference point as the upper right corner and the rotation to go to the left here. We'll hit OK and OK. And elevation facing north. So let's just check with this one. This looks the exact same. Now we want to generate the walls in the floor plan. Find and use the precast plan, generate plan to generate the walls from the elevation to the floor plan. The following window will press OK as we want all our elements to be generated in wireframe. The final result should look like the following picture. Congratulations, you just generated your first walls in Impact. Let's see. Oh, let's go here. And now we want to generate the plan. And in this case, all in wireframe and OK. So let's see if we get the same result as the training material. If we do, we're very happy. And we do that, and we actually get that here, which is really good. So now we're ready to actually continue with the training material. And as it says, perfect, congratulations, you just generated your first walls in Impact. Now, we'll model the rest of the floors in floor plan. So let's go to that one. Modeling walls in floor plans. So walls are drawn in the floor plan to define the building's layout. There are three types of walls in Impact. We just did some sandwich walls on the elevation. There's of course also insulated walls, which is concrete and only insulation, or a solid wall, which is only normally concrete. So in this chapter, we'll use the draw wall command from the toolbar. We will draw only sandwich walls and solid walls. First of all, we'll draw the sandwich, and then we'll draw the solid walls. And we'll draw in the pattern shown below. So just as we did with the slabs, we're only going to draw approximately half the building. We're going to do a little bit more here. Draw full walls until corner connections as the arrows show. We will split the walls in a later chapter. We'll also connect the corners in a later chapter. So how to draw sandwich walls? Press the command draw walls. Select sandwich. Select the starting point and direction for your wall. Use right, left, center alignment option to select in the command field while drawing the walls to, align them with this. Slowly draw the walls on half of the side and press enter when finished. So let's go ahead and look at that. What we want to do is we want to go to wall, we want to draw a wall, we want to sandwich, and we want to start from here. This one here. So you can see it already fits. If I started up here, I could have done left, for example, LE, enter, right, R, as you can see that, it switches where it draws. We'll go to LE so it fits. But you can click these buttons down here to do that. But here we can draw it all the way to here and snap, all the way to here and snap. The corners themselves don't matter so much. What matters is that the walls are placed correctly. The length and the corners here. This one. Here we'll have an overlap, and again, it doesn't really matter. We'll control all this later. Then, if we zoom out a little bit, we'll look at it. It's going to look the same as the screenshot. Unmarked, 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 unmarked. This is just to check, do you actually have the walls compared to this course material? Let's just go in and check. Unmarked, 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 unmarked. Everything is perfect. I can even go here to this isometric view, and we can see the walls here as well. You can even see our elevation walls from earlier. We'll go to top again. We'll go back. Select all the sandwich walls and press Edit Wall. Choose Properties to configure the specifications. Review the different tabs. Make sure you have inner panel up. If not, then you need to redraw the elements and change the properties while you're drawing them. Endcaps. Make sure the top is 831, bottom is 830. Press OK, hit Edit, Update All. Great, so we'll do that. We'll select sandwich walls like this. We will edit wall, properties, inner panel up as it says, end caps, top 831, bottom 830. Hit OK, hit update all, and you can actually see it works its way through them. And then very importantly, end with the exit. Otherwise, it's not going to be configured. We'll go back again. That's actually it for the sandwich panels. Now we want to draw solid walls. And guess what? It's done in the exact same way as before. Go to draw wall, select wall instead of sandwich. Now we'll just draw them as shown in the other picture again. The end result would look like this here. A big wall there, smaller there, one here, one there as well. And then after that we edit them. Let's draw them first and then go back to the editing. So we will say draw wall. We'll take a regular wall this time. Let's start here. And you can see it draws on the center line. So let's go LE I pressed. Right is what we want to do in this case. We're going to draw them. Draw that to here, from here to here. There we go. And now what I can do is hit enter to finish the command. And I can hit enter again to start it, or press the draw wall. So in this case, we'll just take it from here. Again, you don't have to mind this in this part of the training because we'll add it later. Like this, enter, enter again, wall, and we'll take this one as well. Here we go, enter. So now it should look exactly like what we had on the picture. And then what we want to do is do the same thing again, edit the walls in order to change the end caps to top 000, bottom 809. Important. If you select multiple element types and press the command edit wall, then the software will ask you which type you want to edit. So we can easily select the whole building. If that makes it easier, and just press edit wall. It will only edit the walls. Let's do it then. Go here, select the whole building, go to edit, and then the software will ask us, we'll take the walls. We'll go to properties, we'll go to Endcaps, we'll go 000 at the top, 809 at the bottom. I think it was 809, wasn't it? Let's have a look again. 809 exactly. We will say OK, update all again, and exit. There we finish modeling our walls again. Now let's add some openings. Let's add some more details into them. Add openings, the same as in the elevation chapter. Great. We will add the windows and doors as shown in the XREF. Find and use the command precast plan components draw opening. You need to either select a specific wall or add the openings. To add the openings or select none. I think in this case we're going to select none. You'll see when I do it. Important note, it is up to you to decide what you want. If you select a specific wall, the opening will be added on the assembly immediately. However, you'll need to use the draw opening command more times. If you select none, you're free to add different types of doors and windows all over your floor plan. In that case, you will need to add them afterwards to the profiles by editing the walls and pressing add and exit. The windows and doors will be added on the assembly then. So assign the opening name and properties if the opening weight should factor in, and so on and so forth, which it shouldn't. Place the opening in the correct wall based on the architectural drawing. Insertion point. If you rotate the wall view on the floor plan by using the cube on the left top, then the result should look like the following picture. So we've added these ones around. Let's try here. Go in here and we can see, oh, a bunch of F3s. So go to components, go to draw opening, select the element or none. We have more F3s. We do have actually down here. So best to select none. We'll go to F3. Perfect. We'll go OK. And we will insert and rotate as specified here. If you hit it wrong, you can simply select it with a mouse and delete it as well. Just use the delete button. And then F3 down here also. So you can see it's very easy when you do it like this. This is my preferred way at least. Then once we're finished with all the F3s, there's actually another one here. And we can hit enter. Trick again, expert trick, pro tip, hit enter again. Select none. Now we can go with the FD2s. FD2, balcony door, okay. Insertion point and rotation, insertion point and rotation. Those are the balcony doors. Enter again, enter again, enter again even. And we're going to add F21. F21. Press OK. There we go. And there we go. So as in the training material mentioned, they're not inserted into the walls now. You can see they're white. So what do we need to do? Well, select the sandwich panels. There we go. Edit them. Add, as we've tried a few times already. Update all. And now you can see they turn into the same color as the walls have. And exit. We go here. If you rotate the view on the floor plan by using the cube, then the result should look like the following picture. Let's try and see it. You can use this cube and do like this, of course. And then we can see our windows and our doors in here looking all perfect. That's great. press the top again to go back. If you want to edit your openings, then press the command Edit Opening and select the corresponding opening you want to change, no matter on which wall it's placed. We don't need to edit anything here. If you made a mistake and the opening is not added properly on the wall and you want to delete it, then you'll need to double click on the wall, then remove, then single, and then select the window to remove it. So I can show you this one as well. So if we go in here, double click the wall, remove, single, click on the name, update placing anchor. Do you want to remove more? No. Exit. So now we can actually delete this door here. Oh, there's no FT2 in this one anymore. Let's put it back in. Draw opening. Now we can select the element because it's only one. FD2. We'll hit OK. And we'll place it here. Hit enter. There we go. So now we're on par with the training material again. So now, okay, we want to add some recesses in the walls as well. And we can actually use our slabs to create the recesses automatically. So what we can do is we can draw recess from element and use that command. You will select the element to subtract from, which is the wall. You will select the element to subtract, which is the slab. And then you will configure it like in the following picture, depth of 40 millimeters and ensure proper alignment. And then press OK. Then press yes to update lift, and then the element should look like the following if you rotate the model view. So let's try that one. We'll go into this one here. We will add recess by element, draw recess from element, select to subtract from, which is the wall, enter, select to subtract, which is the slab, enter. We don't want it to be a cutout, we don't want to extend it to the top bottom, we want the horizontal gap to be 40 millimeters, and then OK. Update the lifters, yes. And then let's go to the isometric view, just zoom in a little bit. It looks exactly like it should there. We can see this recessive added. Perfect. Let's see here. Great. Avoid cutting installation material during recess placement unless required. The picture above is a little bit complicated to understand. For better visibility, we can isolate the elements and then show a solid representation. Great. Select two elements and right-click, press Isolate Objects. Use the Impact command, Presentation Object, select the elements and then Solid. We should be able to look like this then. Let's go ahead and do that. We'll go to the 3D view. We will select the two elements, right-click, Isolate Objects, Isolate Objects, both of them, go to Plan, Presentation, Solid. Great. That looks good. It looks exactly like it should. Now, using the same command, select the wall and slab, back to the wireframe visibility, right-click, and then End Object Isolation. Remember to draw the recess from element on the other sandwich wall that has a balcony slab. So let's do that as well. Here we go. We will do like this. We'll go to Plan. We will go to Presentation Object, Wireframe. We will select it, right-click, End Isolation. Then we'll remember to do it on the other one. So draw recess from element, subtract from this wall. This is the slab to subtract. The exact same specifications as before. Update the lift, yes. Perfect. Now we got that as well. That finishes that chapter about recesses in walls. You can also do them similar to what we did in the slabs earlier, but this is like a nice automated way. Now it's time to actually split the walls as we did in the elevation chapter. We have a couple of walls that are red, which exceed crane or production capacity. We need to split them into smaller segments. We'll start with a sandwich wall. Select it. We'll use split wall vertical command. We'll select a gap of 0 millimeters because it doesn't matter right now. We're going to handle that later. We're going to select Endcaps to none again, as we're later going to handle it, and then press OK. The midpoint we can set in between the two walls as we have on the XREF, and then press Enter or right click. The wall needs to turn green. Do the exact same procedure for the solid wall, and the final result should look like the following. Good. We'll go to the top. We'll go in here and we will do this split wall. We will select the wall, select the gap of 0, no end cap, and here. We'll take the solid walls. We'll actually look at the solid walls now. Maybe you'll notice something, but I won't say it now. I'll say it later. Gap 0. Okay. And then we'll split it. We can split it here in the middle, but again, that's actually not important right now because we will make a special connection here. So what I just noticed is what we forgot, which is a perfect exercise as well here, is we forgot to add the doors on the solid wall. Maybe we went a little bit too fast with the training material. You can always go back. Or maybe you remember how you did it before because you've done it both on the elevation and on the sandwich walls. Draw opening. Select the element or none. I have two elements now. I'm going to select none. I'm going to select wall. We're going to select D2. Then we're going to press OK. And then we're going to add them, of course. And then again, if you remember, double click, add all. Update placing of lift and bracers. Yes, now we have it. The same thing. Click it, edit, add all. Update lifting and bracing anchors. Exit. So now we have the doors in the solid walls as well. And in the sandwich walls. And we've split the walls up into element-sized pieces. Perfect. Then, just as we did with slabs, we want to mirror the walls. Because the building is symmetrical, there's no point of us drawing the same thing twice. First, we'll mirror our sandwich walls. Select the sandwich walls as shown here. Use the command mirror wall under wall. Select the first and second point of the mirror line. Again, the same vertical theoretical line. Take the midpoint of the building, just as we did with the slabs, and press no to removing the original walls. Then do the same for the following solid walls. The final result should look like the following picture. So now we actually almost have a building here. Let's try and do it. Walls. This one, this one, this one, this one, this one, this one. Go to plan, go to walls, mirror, wall. Find the center point of the building. There we go. And no to remove originals. And we have the walls. Then I'll just hit escape to not select anything. I'm going to select the solid walls. So this one, yes, exactly. Mirror, center point of the building. Remove the originals, no. So there we go. We have everything here now again. So if something is selected, like you can see here, this might just be AutoCAD. artifacts or whatever we call it. So don't worry about that. You can see I just selected everything again and pressed escape. So that is great. If we look at our building now, it's really starting to look like something. We haven't spent all that long, but we're really getting a lot of results here. So now we need to connect the walls. Just as we did with the elevation chapter, we connected just a few of the walls. The difference is now we got to connect all of the corners, all the way around the building. What you need to do is you need to use the connection as what is prescribed in the XREF. So let me just zoom into that. So basically here, you need to connect it with AD6 803. That's what we've decided for you. 804, in this case, 820. So basically we got to work our way all the way around this. Let's go back to the training. Example, select connect wall. Select the two corner walls, right click or hit enter. Work through the joints, find 803 if it's 803 you want. Do 801 if it's 801 you want or need. And then apply that. Then we're going to have this window pop open with casting materials. We're not going to touch that. We're just going to have it. And then we can decide actually the rotation of the joint with next and previous. And then we'll end with apply. That's basically it. Then, of course, we'll do the same all the way around with all the corners. And all the three-way corners, as you can see, there's also. So I'm going to go through all of them. And you will simply just have to follow along, do the same thing. So we'll go to here to the material, zoom in. We'll start up with one corner. So let's go in here. What do we need to do? We need to connect. Find the connect wall command, just as we had with the elevation. Wall, connect wall. Select the walls to the joint, these ones. Hit enter or right click the mouse. There's only one option, 803. So we simply need to hit OK here. Now we can see it suggests where do you want us to actually place this. So if I hit next, you can see that it actually moves it. This is not how we want it. We want it to be like this. So we'll hit apply, update all. Then we'll have the same joint now. So all 803s we can actually do, which is a little bit trick of the trade as well. Now it applies it even faster. Apply. So I'm just going to work through here the 803s. 803 here as well. Apply. 803 here also. So now it's basically just doing the same thing a few times here. Don't skip this. It's a good exercise, but maybe you don't have to do like I do, where you just hit enter and continue. Maybe you will want to run the command again every time. But don't worry, we'll have plenty of possibilities to do that as well. Now we're working through everything. We're doing everything. We're doing it properly also. So no cutting corners here. Apply. I think that comes to the last external outer corner. There we go. Apply. And in this one, we actually didn't get it correct, as you can see. So we'll just change it. There we go. That is correct. Here we go, perfect. We'll hit enter. So enter stop the command. We will draw the command again. Connect wall. Select this one and this one. 804, 804, that's perfect. OK and OK. The origin point should be right here. Apply. Update all. We have more 804s. Yes, we do. We have this one over here. These two walls. Specify the origin right here. Apply. I think that's it for the 804s. If you remember, we already added them up here. We'll hit enter. So now we have a little bit more special ones. We have like these internal solution, which is not more special, but we'll just take those. This one here, only one 801. It's perfect. We'll do that one. We'll hit OK. We'll hit apply. Update everything. We have 801 over here as well. Apply. There we go. Now we have some three-way joints, which it mentioned also. With two solid walls, two sandwich walls and a solid wall. Bunch of slabs I selected also, but it doesn't really matter here. The walls are the important thing. 00, 801, 802. Like this. Apply. Update all. So you can see it really trims everything in, but we need this level of control if we want to do it correctly. So we'll hit enter here. We will run the command again. Join this one and this one. And here we need the 820. Which is probably a mistake because the 0204 one looks correct here in this case. So let's use that one. Here we go, we'll hit apply, we'll update all. The same thing we're going to do here. Apply. Same thing again for here. Apply, next. Apply. Here. Apply. I think we have more of those. Then we have this special one, 805. This one, and this one. 805, perfect, like this. It's only one solution for that. So you can see now it cuts the walls, it cuts everything in as it needs to be. So, you know, where we made all these sizes and so on before, it didn't really matter because it cuts everything into size. Here we will have a three-way connection also. This wall, and this wall. The insertion point, the joint, 806, apply. But we can actually, that was actually wrong. Can you see that? So I hit escape instead. We'll do the same thing again. And the origin will change up to here instead, and then apply, and apply. Update all. Great. We'll do the same for this one again. The origin point there, apply. So we guess we've worked our way almost across everything now. We'll just check which ones we need to do. These ones. Oh, we're missing this one down here, I think. Let's go in and do that one as well. So if there's something even off by 0.5 millimeter here, this is not going to fit. So we'll see if we actually mirror it correctly. If we didn't and it's off by a little bit, we can easily correct it. But we'll see. This one, and this one. There we go. Fits perfectly. Apply, update all. There we go. And actually, I think even though the training material doesn't ask us to do this, we can also do the ones on this small wall here. So connect wall, this one and this one. Okay. Okay. Apply, update all. Same thing with the bottom one. There and there. Apply. So I think now we should have all of them, all the corners connected. We have some yellow walls here. I'm not 100% sure it's going to be addressed in the training material. We'll see. If it's not, we'll actually go in and we'll save them now anyways. This is because they need to be saved, because they were saved before and now we edited them. So basically, you select them. And then save. Yes, please keep the element marks. And then this yellow color is going to disappear because they are up to date and saved, of course. Here we go. Just going to Control S, save the AutoCAD file itself here also. Well, then basically we did all those connections. Let's go to the next step here. Important note, don't save the walls yet. You'll use the casted material template later. And then we'll save the wall. Just save the drawing, Control S, which is what we just did. We just saved the ones that we made the elevation on, of course. But that was it. The other ones we haven't saved. So the summary checklist here is we've created walls with accurate properties and connections. We've added openings and recesses based on the architectural layout. We've split and connected walls to fit production and crane capacities. We should now have joined all connections on the plan. Go through our plan one more time to make sure we've connected all corner connections, straight connections, three-way connections, both for sandwich walls and for solid walls. If yes, then you can continue to the next part, which is modeling beams and columns. Let's double check it very briefly and quickly. Look, there the connection is. The connection is here, 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 here. All looks good. All the corners look great. Everything is connected. Perfect. Even the solid walls. All looks good. All looks well. All looks great and connected. Great, perfect. So, yeah, we finished with the walls. So the next part is modeling beams and columns. So modeling beams and columns. Step one here is understanding the beam definitions. Rectangular ledged inverted T variable, custom sloped custom, single T, variable T, I-shape, sloped I-shape, and so on and so forth. We have a lot here. The beam definition itself includes geometry, reinforcement, and other parameters. In this subchapter, we don't need to edit anything. We will only review the definition and all the parameters that are set up beforehand. So let's do that. Open the section definitions. Go to precast plan definitions, section definitions, under beams, of course. There are two different types of beams. There are pre-stressed and solid beams. You can look at both. I think we're just going to go into AutoCAD and look at one of them. Otherwise, just follow these pictures here. Explore the beam, pre-stressed beam definitions available. Here are some screenshots. Setting up the beam properties. Strand patterns. We'll configure the strand pattern, match the project's current structure requirements. Just view it. Chamfers, lifting points, reinforcement, and then on. And the next step is drawing the beam. Okay, let's go in and just review it a little bit here. So beams, this one here, the definitions, beam definitions. A rectangular beam, we'll edit it. Here we have the geometry and the type, the size as well, the chamfers, lifting rules and which lifters to use, drawing rules and scale, miscellaneous such as rules for naming it and so on, and reinforcement for what reinforcement to actually put in as standard in this beam. We can close this down here now because the next exercise is to actually draw a beam. So step 3, drawing the beam. Start the draw command. Navigate to precast plan, beam, draw pre-stressed beam. In the main view, you can adjust the strand pattern and select the section you want to draw. In this case, we want an inverted T pre-stressed beam definition. LB 58, 48, 24. And we'll go in and do that so we can just follow along with the course material. Draw pre-stressed beam. LB 58, 48, 24. Then go to end recesses. Configure the beam for vertical slope. You can configure. You don't need to do anything. We want to leave it to 0. Fixings. We want to do actually add a single symmetrical circular fixing on each end. So let's do that. We'll go to ends, we'll go to fixings, circular, 150 mil. The other way around, I think, 150 and 50 millimeters big. Copy to the other side. There we go. We'll go in here. Does it look like this? Yes, it does. Make sure in model to adjust the justification point for the insertion of the beam in the model. Lock the elevation so the beam flanges are drawn at the same level as the Hollowcore slabs from the previous chapter. So it doesn't snap to on-screen values. Justification should be bottom center. The elevation should be locked. So let's go and check that. Model, locked elevation, bottom center. Great. Press OK. Then we pick the start point. Define the beam's location in the plan view. Ensure the beam elevation aligns with the intended slab connection. We just did that by checking here. Press offset and type 10 millimeters from left and right side of the beam. Okay. Then we'll actually draw the beam now. We'll hit OK. We'll specify the start point to here. We will go with O for offset. Hit enter. Write 10 and 10. Now you can see it starts 10 millimeters in, and we'll draw it to over here. So now the offset is 10 millimeters, and we've drawn our beam right here. The next step is to mirror the beam. Select the beam and use the command mirror beam. Again, the XREF center line or the center line of the building to mirror the beam. The result should look like the following. Perfect. Let's go ahead and try and see what happens. Select the beam. Go to plan, go to beams, go to mirror beam. We select the center point here. I'll be a little bit careful. Exactly. There we go. Don't remove the original. Just check the placement. Looks perfect. Go check this view here. And it looks exactly like the actual course material again. So all good. Save the beams. Navigate to Precast Plan, Beam, Save Beam. Assign element marks based on the company's conventions. Here we use B100. Reload the model in the project manager and review or verify how the slabs are sitting on top of the beam flanges. Great. Well, let's look at that then. We'll go in, we'll go to beams, we'll go to Save Beam. Select the beams to save. Hit Enter or right-click mouse. We'll give it B100. Enter. Now these are saved. We'll go in to our model. Well, remember, we have not saved the walls yet. Only the walls are created on the elevation. So we should get the elevation walls over here and the beams here. Those are the new elements we've saved. So let's reload the whole model here and we'll see if it's actually as we intended. Or we get more than we bargained for, of course. It should be. So there we go. We have the beams over here. One beam, two beams. Do the slabs and Hollowcore sit? Well, they do. A little bit of a gap here in this case, depending on how much you need as your company for the gap. Of course, 10 millimeters, 20, 30, so on. It looks correct. Again, this is how it looks in the training material. This is how it looks on mine because I'm using a different view property, different visual style. Shaded with edges instead we can also do. Just depends on your preference. So now the next step is to create columns. Now we'll go to the column definition. In this case, it's very similar to beam, just that it's a little bit more simple because we have rectangular, circular, and then custom. If you would like to review the column definition properties, then select the column definition button and look into the rectangular column definition called RC4050. This is almost identical to the beams, so I don't think we need to do that. Step 2. Defining the column parameters. In this step, we will make changes to only in the predefined reinforcement tab. Okay, so basically we will actually go in here. Anyways, so columns, column definitions, RC40 by 50, edit. We have it here. Height and width needs to be 500 by 400. Material needs to be concrete. Just view the lift, view the chamfers, and then do something in the reinforcement. Great. Let's look at that. Chamfers, lift, drawing, MISC, the exact same as the other one. But reinforcement here, we want to do something. We need to add some template for it. Right click in the gray area, hit new. We'll call it L6102 underscore 1 plus 5 plus C300. New L6102 underscore, and now I forget it, who can remember that name here, underscore 1 plus 5 plus C300. 1 plus 5 plus C300. And OK. So now we get this dialog box up here. Interesting. We're going to select, in this case, bar mark 6107. Location from top 400, bottom 500, spacing 300. 400, 500, 300. 6107, I think it was. We'll just double check that again. 6107. There we go. 370, 300, 6107. Let's go in here. 6107. Perfect. 370, 30. Go to straight bars. Fill out the straight bars as shown in the picture below and then press OK. Basically, we need the cover to be a little bit bigger so that everything fits. Straight bars, cover needs to be 40. B1640, 100. Let's just go in and double check. B1640 100. Perfect. Fill out the cover bottom and then bottom and top and then press OK. So we will press OK. And we're here again. Cover bottom, top, that's what we forget. Cover bottom, cover top. And put that cross here. There we go. 25, 25. And then press OK. And press OK to save. OK and OK. It's very important we press OK here. If we press cancel, we cancel everything that we just looked at. Step 3, draw the column. Navigate to precast plan, column, draw column. We'll do that. Select RC 40 by 50. Lift hole distance from top 785. Insertion point, middle, center. Press OK and place the 4 columns on the drawing. Use your mouse for the correct rotation of the column. And they should look like this, with the lifters being there we go, placed like that. And we will see here. So we'll go to top. We will draw columns. 785, 2615, 2615, 785, RC 40 by 50. All good. We will hit OK. And now we can rotate them also. So you can see I can do like this and rotate them. The rotation here, of course, controls where the lifters are. In this case, of course, you want to rotate them so that the lifters are placed where you want to be. If I rotate this one like this, the lifters are going to be over here. If I rotate it like this, the lifters are going to be here. So this depends on maybe when you set it up or the ease of making it, the corbel and so on. If I do like this here, we're going to have the lifters inside, the lifters inside. Same thing here. For the course material itself, this is not important, but for your production, it is, of course. There we go. Now we have the columns as well. The next step is adding corbels to the columns. And we have an automated feature for this, which is perfect to use in this case. Open the corbel menu, navigate to precast plan, components, corbel, draw corbel from element. Select all the columns and beams in your drawing and then press enter. Select the corbel definition and the location will automatically be adjusted. We can specify the gap, which should be maybe 10 millimeters. At the end, it should look like this. Good, so let's do that. Go ahead and do that. So we will say, draw corbel from element, select objects. We'll select all of them. Here we go. Hit enter. The corbel is right here. Simply press OK again. What should the gap be? 10 millimeters, perfect. We'll hit enter. And there we have it. Now we have corbels on our beams as well. Great. Everything looks exactly as it should. We'll hit Control S just to save the drawing again. So now we want to save the columns. Navigate to precast plan, column, save column. Assign element marks based on your company's naming conventions. Columns use C100 to C199. For verifying the placement of the columns, go into the Project Manager model view, check how they look in comparison to the beams and the Hollowcore slabs. Press Reload Model to generate the newly created column in the model view. Should look like the following picture. In the project browser, you can select the Hollowcore pre-stressed beam and column, and then right-click, and then use the command Visibility Isolate. And that way, you can filter elements from the model view for a better understanding of the model. If you want to end the object installation, use the command Unhide All. We'll look at that later also, or double-click the model in the project browser tree. Okay. So let's go in here, save the columns. C100. They are now saved. We'll go back into here. And we will reload the model. Perfect. So now we will also have our columns here. So we have everything that we need. Just as it said before, if you want to isolate something, you can go in here and go isolate Hollowcore. Now only the double T's we made with the Hollowcore tool and the Hollowcores are visible. Visibility, unhide all by right-clicking, or unhide all up here. So now there's an optional practice exercise. Draw a double L-beam with the chamfered edge and custom strand pattern. Create a rectangular column with a corbel for beam support. Save both elements and assign appropriate element marks. Basically, that's what we just did. So this takes us to the next step of the course, which is something we call linked elements. And in this case, we're going to use the linked elements to model stairs. Modeling linked elements stairs. So what are linked elements? Linked elements are composite precast structures like stairs, foundations, custom assemblies that can require the integration of multiple components, slabs, walls, reinforcements. These are essential for complex architectural structural design. Well, but that basically means that any element that is not completely 100% automated in impact, such as the sandwich walls and walls, it might be stairs or it might be custom column foundations or something, can be done with linked elements. So the first exercise here, we can see that before starting the linked element, it's necessary to draw some solid slabs at the bottom of the building in the area below here. Open the floor plan drawing GA0101. We'll go in here, we'll go to floor plans, GA0101. Open the EWG. There we go. And this is the area where we want to draw the slabs. We want to use the command draw slab, just as we've done earlier. Use the properties below. Make sure to change the elevation to 15. It will be on the bottom of the building. So the elevation should be 15 in the model tab. Then we draw multiple. And we will select the bottom left corner as the insertion point as well. And then we will save the slabs and use names SSS001 this time and above. Final result should look like the following. So I went through this a little fast, but that's basically because we've done this several times already. So we'll go into slab, we'll go to draw slab, SS19, model 15. Okay, we'll do multiple. We'll do it as a window, W, enter. Sorry, select the first corner point. You can see now I hit something instead. So I'm just going to stop by clicking escape. And I'm going to say draw slab, SS19, 15. Okay. multiple, specify the first corner point, which would be here and here. Did it say anything about Endcaps earlier? It doesn't specify anything about Endcaps. So in this case here, let's just go with none. Copy to all. Zero. Copy to all. Apply. No slope. The base point here. You can see now the rotation goes upwards. I can hit R for rotation, meaning that we can do it like this. We'll get the cut slab exactly like the training material. Hit apply. And here we have the slabs. Exactly like it said here. So the next step for us is how to create a stair. A stair is defined as a linked element in Impact, meaning it cannot be generated directly from the database. It requires linking a shop drawing and a floor plan. This example will draw a very simple stair and landing. Connections between stairs and landings, as well as creating much more advanced geometries, are also possible using Impact Linked, but for now, for the sake of the beginner's course, we'll just stick to the simple stuff. And the exercise is creating the simplified stairs. Steps to create a stair. Draw a sketch of the stair on the floor plan by using a boundary polyline or the command rectangle. And then for the steps, draw regular lines. Make each line 2500 millimeter offset from the last. The sketch should then look like the below. You don't have to do dimension lines. So we'll just sketch them on top of this piece here. So we'll zoom in. We will do a rectangle like this. We will do lines. Here. I think it should say probably, I was going to go with 2500 millimeters. I think it should stay 250. 250 millimeters. Straight across. We can simply copy or draw more. In my case here, you can see I'm just drawing. $50, $1,500. Too many, there we go. So here we have the sketch, somewhat similar to the one that we looked at here. 7 times 250. Alternatively, use the prepared stair drawing from the folder of the drawings, but well, basically we just made it. Then go in, use precast plan, linked elements, draw stair to link the elements. Let's go ahead and do that. We'll go in, precast plan, linked elements, draw stair. Select the layout, select the boundary polyline and the steps drawn as lined. And select the insertion point. You can use that up there. We'll try to do that. There we go. We'll take this one. Here we go. Enter. Insertion point there. Specify the rotation. I don't know anything about a rotation. So we'll set to 0. So 0. did not work that well, so we just put it to the other side instead. Maybe we'll pick it again, so you can see here. There we go. Rotation, 0 to this side here. There we go. It looks a little bit more correct now, like the arrow. Now it looks very tall. Well, that's because the height is of the whole floor, of course. So we'll go in and check. Height set to 1400. Recess 290 and 60. And 60, and then click element mark. Element mark M001. And then top inform as top in this case here. We'll hit OK. And OK. Specify the mark insertion point. We can place it here. Insert more elements, it'll ask us, and we can press no. We'll just go back to this one. There we go. And now we're ready to draw a landing. Before we go and draw the landing, I would recommend that we go in and look if it's correct what we just did. And we can see, well, it looks all right. Looks perfect. Linked element, in this case, are not a super exact science. So, go in and check how it was. Is it actually as you intended it to be, and so on. Otherwise, go in and change it again. But here, this is perfect. So, draw a landing. To add a landing between the stairs, well, basically, we'll just do a slab again. So as you can see here, now the elevation should be 1215. Zero millimeters for the support length, none for the end caps. Copy to all sides and draw it in this area here. We'll go in to this one. We'll go to the top again. We will go to slab. We'll go to draw slab. Was it 1215? We'll just double check. 1215. Single window. Select this to 0. No end cap. Copy to all. Apply. There we go. Now we have our little landing as well. And the next step, it says convert the slab to solid form and update the floor plan. Precast plan, general, presentation, object, solid. Great, let's go in and do that. Select it, plan, presentation, solid. We'll go in, just check if it looks all right. And it does. You see the picture isolated here. I'm not going to isolate it again just for the sake of that. Use the command save slab and use the name SSS 003. So we'll go back in and go to this one. And we'll use the command SSS 003. Basically, what we forgot before was also to save the other slabs. So let's just go ahead and do that. Slabs, save, selection. SSS. We'll just go with 001. We'll let impact decide the rest for us. So you can see, well, even I forget to put save the elements. Well, you can just go in and do it at any time. SSS001, SSS002, SSS001, because they're the same, and SSS003. Draw the other part of the stair. If you want to add the next part of the stair, please use the following steps. Precast plan, linked, insert linked. Select the element marked to be M1 and press OK. Insert the M1 stair like in the following picture, the edge of slab. So depending on how we put it in now, we'll insert it. So we will say go to linked and insert linked. And we'll go to M1, go to OK. Insert it like this. Oh, sorry, as you can see, I actually moved it too far to the side. That's not a problem, because we can just take it and move it to there. There we go. So we'll go in here. This has been put in. Rotate it like this. It's going to look like the following. Don't worry. Let's check how ours look. Yeah, so it's down here. What we wanted to do is, of course, continue up to the next floor. Don't worry, the course material said. Use the CAD command move and move the stair to the point in the 3D model that you want in all 3 dimensions. Let's go in and do that. MOVE, specify the base point, and then do here, probably, right? So now we moved it. For the changes to be applied in Impact, you will have to use the command precast plan, plan, update, plan. Well, let's go ahead and do that then. Update plan, right up here, precast plan. Check update for updating the element. Fine, finish. Review the elements in the project manager by pressing the command update. Okay, let's try and do that. Let's go back to the project manager, go to model view, just hit update instead. We should be able to see our slabs, stair landing below here, which we do. So it looks perfect. Landing, stair 1, stair 2, slabs here as well, all good. You can revolve around, zoom in and out, isolate all you want, of course, if you want to make sure it's correct. That's it for the linked part of the exercise as well. So in the next part, we're going to create some endcaps, which is, one of the most used things in Impact, especially for walls and sandwich walls, is what we use to actually connect the walls. And you used endcaps already in joints. You used it already in tops and bottoms, on slabs, a lot of places. So let's go in and check that out, see how we can create our own maybe. So yeah, now we came to this one here, create endcaps. So after drawing the main layout of our model, while using some of the most common precast elements. In the following chapter, we will now then review, draw, and understand one of the most important functions, the end caps. So what is an end cap actually? End caps are configurations applied to the edges of the elements such as walls and slabs. They define specific geometric properties and material settings, ensuring compatibility with production and assembly requirements. Common use, chamfers, insulation layers for walls, joints, connections, wall to wall, and so on. So what we want to do is we want to create some new ones. So, accessing the Endcap tool. The first step here is to open the Endcap walls drawing from the project manager. It's called 200 Endcaps walls and is under other drawings. It should then take us to here. Let's go ahead and do that. Drawings, other, Endcaps walls, and then it looks like this, exactly like the course material, which is great. And then we'll go in here and have a look at it. So step 1, open the Endcap definitions. Navigate to Precast Plan, Components, and Endcaps. In the dialog box, you'll see a list of existing Endcaps for sandwich walls under the specific project folder. Select New to create a new Endcap, or Edit to modify an existing one. If you press Edit, then you can review one of the existing definitions, WD34801. Press OK if you want to step out of the definition. So let's go in here, go to Endcaps, under Components, Endcaps, which was the one, 801. We can go in and look how it looks, but everything will be explained anyways in detail later. So we can close this one down, I think. Creating a new Endcap for sandwich wall. We're going to draw Endcap WD34807 as shown in the drawing. So under the command Endcaps, press New and give the Endcap a name and a description. So I'm just going to take this one, put it on my other screen so I can actually see what's going on, and I'll write the name in the description. So we're going to go again to Endcaps, and we're going to say New. We're going to go ahead with WD34807. We're going to write side SW 120, 150, 70. That takes us to this dialog box. Let's go back here then. Step 2, define geometry, reinforcement, and layer boundaries. So a little bit of general information before we start to do this. There are 3 levels of information on Endcaps. Level 1, which is measurements and so on. Level 2, which is used in previews. This is details and measurements. And then the database level at the top here. The database is the geometry that Impact uses to actually create the geometry in the 3D space. So now we will start by selecting the geometry, the database level. So first we're going to select geometry. What are we going to select? The outer layer of the Endcap, and make sure to set the origin point to the bottom left corner. So let's do that. Select geometry. Origin point should be there. The polyline is here. There we go. That's the first piece. Unmark the visible point number 3 in the picture below. Okay, let's just go nice and quiet here. There we go. That one we unmark. The blue window above shows the points of the Endcap that want to be visible on our elevation view of the shop drawing. In this case, we only want the start of the Endcap to be visible, so this piece here where the angle starts. Select reinforcement boundary, which is the red line. Note, the reinforcement boundary allows us to place reinforcement no further than the red line indicates. In that way, we ensure that the template reinforcement will not exceed the element position. So let's go in and do that as well. Reinforcement boundary. We select that to here. Now select the layer boundary. This is only for sandwich walls and insulated walls, of course. Very important. for sandwich walls, always select the first layer as the one that is up to the inner panel, this one down here, and then the layer for the outer panel, which is this one up here. Then you'll have the arrows pointing as here in the picture. Let's go in and do that. Select layer boundary, here, and here. Now we have the arrows pointing as it should. Basically, in this case, that's what we needed for the database to understand and create this detail. Now go to level of detail 1 and use the command select objects. Select everything and press enter, or right click. Specify the insertion point, bottom left corner, and then it should look like this. Level 1, select objects. I'm going to pick everything except this piece down here. Hit enter. Click, there we go. That's the detail it's going to put on the drawing. Now go to level 2 and select objects. There we just select this piece in here because it's going to be shown as a symbol for creating joints and so on later. Again, the insertion point needs to be in the correct place. We even want to keep the insertion point of it so that we can later refer to it. So we can go in here for number 2. We'll select just this in here, the insertion point. There we go. Maybe we don't need this actual one. So we'll select again. There we go. There we go. Now it looks correct. Press OK and then again OK in the main view of the Endcaps. Now your Endcap is saved in the system. Well, let's go ahead and do that as well. OK and OK. As you might have noticed, in the Endcap window, there's the general geometry, and then there are 2 more tabs, the casting materials and reinforcement. For the sake of this example, we're not going to use predefined casting material or reinforcement inside the Endcap. It's worth mentioning it's actually possible to do so. In order to verify that our Endcap is done properly, we can always go back to the floor plan, use the command draw wall, the properties, you can press P while drawing, and assign the Endcap on the sides of the wall. If the Endcap can be found in the window of Endcaps, that means that the dimensions are created properly and fits our wall definitions. So let's go. I still have my plan drawing open from earlier, from when I made the linked elements and stairs. We're going to go in, we're going to do a sandwich panel, start here, hit P, Endcaps, left and right, side SW120, that's the one we just created on both sides. It was top, sorry. On left and right. And we'll see here. Perfect. Looks great. I can even go in here, presentation object, show as solid. This is how it should look. Great. I'll just delete these ones again as we don't need them. Then we'll create our own Endcap. Now we get an exercise. Follow the steps above and create the Endcap WD34808 in the system. Make sure to verify that it fits our sandwich wall definitions called SW34808. Okay, so now we're going to do everything ourselves without following anything, which is this one. So let's go to Endcap, Endcaps. Going to make a new one, WD34808. Training piece. I don't know what this should be called. Okay. Select the geometry, origin point, and then the green line. The reinforcement boundary, it actually doesn't have one. In which case you can select the green line again, or just don't select one. Layer boundary, this one, then this one, as you can see there. We actually don't want this and this to show either. We only want the one inside to show. Level of detail 2. Zoom out. Go to level 2. I'll select here, enter insertion point here, level of detail 1, select everything in this one, enter insertion point here again. There we go. That's it for this end cap as well. We'll hit OK and OK again. WD34 808. Let's just go back, test it out just as we did with the other one. Draw wall, sandwich, P for properties, end caps, 808 training piece, 808 training piece. Here we go. I'm going to go in and select the presentation to solid. Looks perfect. Very quickly, that's how you create the end cap. You know, when you're not learning how to do it or when you know how to do it. So it takes seconds to make a new one. So what about a solid wall and a slab? In order to create an end cap for solid walls, the steps are exactly the same as for sandwich walls, except for 2 steps. Let's go in, create the new end cap under the corresponding element type, meaning wall, slab. There's no need to select the layer boundary, only one layer of concrete. All the end caps in the existing drawing for walls are already created. If you would like to try creating one for a slab, then open drawing 900201 and draw the end cap for a solid slab called DD19801. So basically, there are no solid walls that we need to create. That's also fine because we already did the sandwich walls, which are much more complex. We're going to close this drawing down. We're going to open up the end caps for slabs. DD19801. As you can see, oh, the views are not there. The insertion point is not there. What do I then do? Well, I'm going to give you a little trick here. We're going to go into end caps. We're going to go into slabs. We're going to make a new one. Call it DD19801. Training end cap slab. Select geometry. The origin point now, oh, that's actually here. So it didn't even need it. And the polyline. Can you see that? Reinforcement boundary, there isn't one, so we don't need it. The level of detail 2 is the symbol. So basically here again. Then the insertion point. And the level of detail 1, which is where we select all of it. In this case here. Insertion point. There we go. Here we have an end cap for a slab. And in this case, we wanted to show those bends that we have. OK and OK. So now we can use that on the end caps for our slabs that we did before. So we can use that connection. Simple as that. Now we created 2 end caps for sandwich walls, 1 for slabs. We can create for solid walls as well, anything we want to do. We know how to now. Create cast-in materials. So now we'll go into how to actually create 3D cast-in materials to use in templates, to put onto elements and so on. We'll go to this one. Create sim, cast-in materials. What are cast-in materials? Well, cast-in materials, I'll read a little bit again here, refer to components embedded in the precast elements during production, including you can make it as reinforcement, but reinforcement will be made with a reinforcement module, of course. Fixtures like anchors, lifting loops, plates, and inserts. Utilities like electrical conduits, pipes, embedded mechanical things. And that's basically what we're going to do here. So creating a new cast-in material. Step 1, open the cast-in material drawing in PM. Go to Other, open the drawing 392341, which is right here, cast-in materials. We're going to open that one. And we have something here already, some views and some 2D stuff. So a little bit of an explanation of how they work. We create the custom materials in 3 views, top, front, and right. And then the program will use these to create a 3D cube. When adding a custom material in Impact, we need to ensure that it is designed as a 3D solid. Luckily, most of the custom material providers worldwide have the catalogs created in DWG format and can be accessed through their websites, no extra cost. In that case, you can always download it. In this case, we're going to draw it ourselves. So, inside the drawing 39, 23, 41, you'll find a 2D representation of a welding plate. We'll need to use this to create the 3D. We need to use 3D CAD commands in order to create this as 3D. So draw a rectangular polyline around the plate and use the command extrude 15 millimeters as shown in the drawing. Okay. So we can make it here maybe. Rectangle. Extrude 15. I'm just going to go to the southwest here. There we go. There we have it. Extrude 15 millimeters. Now let's make some legs. Draw a polyline that covers half of the leg. Use the command revolve and rotate for 360 degrees. Great, we'll do that then. Gonna do like a polyline here. And then snap using our best CAD features here. Close it. Revolve. Specify an axis start point, an axis end point, and 360 degrees. Now we should be able to see that here again. There we go. There we have it. Use the command 3D rotate and let it sit vertically on the drawing. Copy the leg from the top middle base point and move it to the correct location underneath the extruded plate. Okay. 3D rotate. I'm going to pick the red point up, and then we're going to copy CO using this base point here, and then place it into the center of these circles here. Perfect. Now draw a diagonal line on top of the plate. That is necessary for us to have the midpoint of the plate, and this will be the origin point for inserting the plate into impact. Okay. So we'll do an L for a line. There we go. We have that diagonal line. There is a possibility to use the command union and make the different 3D solids components into one. This is not proposed as it will be more difficult to edit if our dimensions are not correct. Okay. Well, then we actually made it, we draw it now. How to make impact recognize it and use it as a custom material then? Well, we will go to precast plan components, cast in materials. Many created in the project folder. Press new and give it a name. So we'll go in here. Precast plan components, cast in materials, new 0001. I don't know what we called it. I'll call it custom welding plate. Press OK. The following window, please select the group and the level of detail to be 3D. Then press select objects on view 1. So group needs to be 3, symbols, level of detail need to be for 3D, and we need to click this one. 3D, group needs to be 3, select objects, and then, okay, what do we need to select? Select the whole objects without the top line. and then select the origin point. Okay, that's fine. So we select this one, this one, this one, and this one. Hit enter. Select the insertion point. There will be 3 questions asked. Answer yes to all, and for the last one, press 2. But just hit enter 3 times. Yes, yes, 2. There we go. Now we should have a picture that looks like this. Change the level of detail back to 2. Fine. Press OK and then OK again. Good. I'll go back here. Change it to 2. Fine. Press OK and OK again. Open the floor drawing GA0101 and draw a solid wall outside of the main floor plan definition WP20. Navigate to precast plan components, casting material, draw casting materials. Good. Let's go to the plan here. And let's draw a wall. Wall. Zoom in a little bit. Let's just make it like this. Here we go. Select the element, go to precast plan components, casting material, draw casting materials, as mentioned before. Draw casting materials, select the element. We'll get a window popping up here like this. Review the different settings, but after that go back to the original and press OK. So how many pieces do we have? What side should we specify it on screen? What should the elevation be? And so on and so forth. Assign the casting material to the wall. You can add multiple after adding the first one. Try and see how you can add on the different planes also. You can always try and add more casting material. So let's go back here. Let's click OK. And we actually forgot to select our new welding plate, which I'm just going to do. Draw casting material, select element, 3, and our custom welding plate. We can add one like this. Or more. Hit enter to stop the command. Go to Southwest Isometric instead. Hit enter again. Doesn't work like that. We'll hit draw casting material, select the element. Go with this one. As you can see, some different things we can do here. How do we want it to be rotated? How do we want it to be set in? And it just shows it in 2D for us. But you can add as many as you want, any way you want here. Go to the presentation, go to solid. We'll see how we put them in actually as well. Casting materials can be used for casting material Endcap templates later, which we'll use later, which is a very advanced feature and really powerful in impact as well. We'll delete this one. Now we tried our new custom casting materials also. So the exercise was we created a wall on the elevation view. We added welding plates. You can also add wire loops if you want to here. Move to the Southwest Isometric view in order to add casting materials on the different surfaces of the walls. Well, basically, we've done that. Taking us to the next step of reviewing joint connections. So we've already used joints when we were making the drawing. So now we're coming to the point of like reviewing what it actually is. And joints, of course, is like joining two elements together. You can call it very simply. In impact, a joint is made out of two things: Endcaps and casting materials. That means that impact and combination between the Endcaps and casting materials that will allow us to create the joints. In the software, we don't use the command draw joint, but in order to apply the joints, we use the command connect wall. So if you want to refresh how you do that, you can go back to the chapter for walls. We're not going to do that in this video. You can what's it called? Go back in the video to view that, of course. Okay, so review an existing joint. Only view, do not change. Navigate to precast plan components, joints, precast plan components, joints. Edit. In the window below, we select our end caps and place them in the corresponding position of the cross, position 1 to 4. For every element type, we have to make different predefined connections. In this case, positions 1 and 4 are selected for the inner corner, but in theory, we could have easily selected positions 2 and 3, or 1 and 2, or 3 and 4, as long as the end caps are rotated on the correct side that we want to represent. That's the first window. Casting material. In here, we position the casting materials inside the end cap. It could be like the welding plate we just created. How they should be placed in the set direction. And we need to select the correct ones, and then how we want them to be placed up during, on the sides of the wall. The different ways of doing that, and I'll show you that as well. For linear casting material, this is not something we go into in the beginner's course, as it's a more advanced feature that combines with something that's called linear casting materials, some that are continuous through the height of the wall as part of the connection, and reinforcement, where we can actually add reinforcement directly into the joint and use it as erection materials. We're not going to use it in the beginner's training either, but it's good to know you can do it. So, what we're going to do is we're going to go into this one. We're going to go into the joint. And we can see, okay, here is the window 1 and 4, end caps 802, 801, mirror minus 278. That's it here. Casting material. We'll go in joint 86, 00801. Then we have these 0344 instead. View 5, view 2, minus 70, minus 20, minus 378, minus 20. This is just how they're placed. If we go in and write 50 here, you can see the placement is changed. And these two tabs we're not going to touch. I'm just going to press OK here. And then we can actually go in here and say, okay, there is an exercise. Create the same joint from scratch while using different positions of the cross and also wire loops. The wire loops are called 0241 and 0242. Then we can try and draw two sandwich walls on the floor plan with the 90-degree corner and apply the new joint. Look at the result in 3D. So let's go in here. And let's actually be a little bit lazy because nobody creates anything from scratch. We'll copy it. 86, 00, and we'll call it XXX. Coordinate cylinder, wire, loop. Edit. So this is like an internal corner. This is fine. If I don't mirror it, it's going to look like this. If I do mirror it, it's going to look like this. If I don't have minus 278, but minus 50, you get my drift. And then what we want to do is we want to change the casting materials to 241 and 242, which are the wire loops. 241. And on the other one, 241. Maybe we'll take this one and give it number 242 instead, which is like a bent in one. Rotation, 90 degrees, 270 degrees. If you can see this one. Y, instead of minus 20, we're going to give it 75. Minus 75, sorry. Minus 75. The reason why it's minus is because the insertion point is here and it's not 75, it's minus 50. This should fit, of course, with your end cap itself. Where we have this as minus 70, we need to move it out into this one here. And you can go out into your end cap or to your wall and of course measure it, no problem there. So right now I'm just winging it, as you can see, which is completely fine. 378 plus these two, maybe something like 300. 325-ish. That was too much. Here we go. Looks good with the while loops now as well. All perfect, all good. Placing we can look at, only 2 while loops. Let's go ahead and change the setup to put 600 millimeters in between them instead. Hit OK and OK. So now we're going to draw some walls. Sandwich. To make the corner. We'll see. We'll join the walls here. XXX 90-degree corner wire loop. We'll click OK and OK again and apply. So that's our new connection we created with wire loops. Perfect for the exercise here. Now we're ready to continue with the next part, which is cast-in material templates. Cast-in material CIM templates. We call cast-in material CIM in Impact. What is a template? Well, it is like a predefined set of rules, and that's for automating the placement of the cast-in materials on elements. It uses Endcaps to define where it wants to put the cast-in materials. Anchors, lifting loops, some things like that at regular intervals along the edges of a wall or similar. Embedded conduits, reinforcement bars in a specific way that go upwards outside the wall, or automating repetitive placements for different element types. So accessing the cast-in material template tool, open the SIM templates menu. Review an existing template. If you open the one called WD34V plate and then move to the table of SIM and press edit. Let's go to that. Components, cast-in material, templates, and WD34V plate, WD34V plate, edit. Browse through the existing templates to understand how they're structured. If you open the one called WD34 plate, then move to the table of SIM and press edit. Table of SIM, edit. Okay, let's go in and do that. Edit. Takes us to this window here. Press OK to move out of the SIM definition and press OK again. And now what we want to do is we want to create a new one even. So this is basically how it looks. Okay, then we'll go back and hit new. and it needs to be something like below. The picture above shows a vertical joint between two solid walls. The item should be placed at a distance of 1/4 of the full length from the ends of the wall. Provide a unique name for the template that includes element type and thickness of the wall. We can call it WP20 vertical. Insert in tub, plastic tub in bottom. I'm just going to move that here so I remember it. WP20 dash vertical. Insert in top, plastic tub and bottom. Okay. Under the table of sim, press New to start selecting an end cap and add a specific sim. Following window will open. Follow the information as shown below and press OK. So we need to select Endcap VD20809 and we need to select the casting material like this and fill it out as accordingly. I'm just going to move it to the other screen again, just like I did before. We'll click New. We're going to select Wall. We're going to select Endcap 809. We're going to select the group 05, which is whole. Going to select 0505, which is this one. We're going to go into view number 3. We're going to select a dimension from site B. Countersink it 100 in Y. I'll move it 100 in Y. Rotate it 270 degrees. Only dimension it in the X direction. And basically that's it. We'll hit OK. Then I'll move this here, create another new one. And then this time the insert with a different end cap. So I'll make a new one again. I'll go with wall 000, group 2 fixtures 0215, view number 2, side B. You can see it lights up here. 100, rotation 90. There we go. And only in the X direction again. And OK. Now we've defined what casting material needs to be put into the element when these end caps are present. Now we need to define the top placement. We'll define it as setup 2, and the A should be 4. The length divided by 4 is the placement. The same thing at the bottom, 2, the length divided by 4 as the placement. Okay. Placing top, 2, 4, placing bottom, 2, 4. Okay. Press OK and then OK again, and your template should be saved and will be ready to be applied. Hit OK again. Okay, test it. Apply the template to a test element. Draw a solid wall using the definition WP20 and apply the end caps used in the above template for the top. VD22000 and bottom of the element VD20809. Precast plan components apply template. Select the newly created template and apply it to the element. So we'll draw a wall like this. And just some extra stuff. I'm just going to copy this wall just for you guys to see. The whole point of this is like an extra thing. When following the video, you'll get this extra information. Properties, end caps. The top end caps, we want to be 000. The bottom end caps, we want to be 809. Okay. Update all. Exit. And then we will apply our new casting material template. Components, casting material templates, apply. Select our new one. OK. And then we can actually go in presentation object, show them solid. So we'll have the bracing inserts and we'll have the plastic tops all the way upwards. If we don't want the plastic tops in the bottom of the element, earlier we actually learned how to remove stuff from an element. So you can always go in here and remove, single, this, and this. Exit. Here we go. Now they're gone. And now we have these four elements on top of each other, connected. I'm going to delete this again, as this was just part of the exercise of how to use it. Verify placement. I guess we've just done that. Step 3, adjust the template if needed. Step 5, applying templates in the main project. So basically, open the drawing GA0101. Navigate to Precast Plan, Components, Apply Template. Select all the sandwich walls that do not have a straight connection and Endcap 804 on the sides. There's already a template called W34DV plate. Select the template and press OK, then wait for it to be applied. Save the updated elements with the same element mark if needed. So we'll go in here and we will apply the template, apply template on the walls that do not have the straight connection. And we're going to apply it to the ones with 804 that doesn't have these in them. And we were a little bit too fast, of course, before when we were doing the joints. So basically what we want to do is select them like this, hit enter, and then applying the V-plate command. What does it actually do? Edit the end cap edge, edit. If you have the edge 804, it's going to put in a welding plate. So we'll just hit OK. So you can see we already have the welding plates. Just put them in, make sure here. You don't have to add it again if you did like me on the video and followed along in the video here. If you don't have the joints here, of course you can. If you remove the items, you can also. But in this case, we don't need to add anything more. This is just a different way of adding it for the joints. So now it asks us to save all the sandwich and solid walls. Do we remember how to save? Go to Wall, go to Save. Continue with the name conversions from SW107. Press Enter. Do the same for the solid walls. The name from them should start with W100. Great. Now we'll save our last elements here. I'm going to do like this now. Plan, Save. Sandwich 107, that's fine, that's where we want it to continue from. And then we're going to go ahead and save the solid walls afterwards as well. So let's let it work its way through all of the sandwich walls. They're going to take a few seconds. So again, in between 3 seconds and 30 seconds maybe. Again, if you have a lot, it might take more. If you don't have so many, it might take less. And then we're going to save the solid walls. I'm going to select everything again because I only select wall here. WP100. There we go. Go back here, and then it says, view the elements in PM after reloading the model. The following picture shows you what your first floor should look like. Perfect. Let's go ahead and check it out then. Just go into AutoCAD, confirm everything's been saved. It has. Looks good. We have numbers on all the elements. So now we'll go into here. We will update the model and we'll check how our floor looks. Looks good. Now we have our walls, sandwich panels as well. Set the element color up here to none maybe instead. We'll have a little bit better detail here. So really good. This is what we're aiming for at least. So nice and as meant to be. So that means that we can move on to the next part in the course, which is duplicating and modifying floors. Duplicating and modifying floors. So basically, without having to read above the text again, you can copy floors in Impact, and you can copy them in the project manager. So in other software, it's common to duplicate or copy in the CAD software, but in Impact, you don't have to do that. You can do it in the project manager. So after that is done, then we can go back to the CAD software, generate the new floor, and modify it accordingly. So what we're going to do is back in the project manager, we're going to the project browser. We're going to select the whole floor to duplicate, right click on it and use command copy elements and element marks. Let's go in and do that. Floor 1, copy elements and element marks. Marks everything up here. We want to copy to floor 2. We want to increase the element mark and drawing number with 100, and then we want to click copy. 2, 100, and then copy. Now, this is the confirmation that the walls of the second floor will be differently named than the ones we already created, and the slabs and so on and so forth. Click OK to create the duplicate floor. The new floor will appear in the project manager with all duplicated elements visible in the model. So we will go in and do that. And hit OK. And give it, of course, a few seconds to copy the whole floor. So now it's everything we just did up until now, the last couple of hours. We will now get everything done automatically for us on the new floor. Of course, here we need to go in and edit some minor things maybe, but I'm pretty sure that that's a part of the actual training course material also. So let's see here as it reloads the model. Now it's finished copying it, and it's just going to reload the 3D model for us. As we'll let it load here, it's going to take a couple of seconds. Let's go in and check what we should do. And it says we will copy elements to floors 3 and 4 later because we want to modify duplicated floors in the CAD. We want to create a new drawing for the second floor and generate the elements. Okay. Create a new floor plan drawing called GA0102. Write the name and press OK. Select floor 2. Check the elevation. Good. That's what we'll do then. First, we'll check. Everything looks as it should. It definitely does. So that's perfect. Then we'll go to floor plans. Make a new one called GA0102. Hit OK. Second floor, the new floor elevation. Open the drawing in CAD and then use the command Generate Plan from the Impact Plan tab. Floor 2, all elements, and OK. Then it should look like the following picture. So we're going to go to Plan, generate plan, all, floor 2, and now it's going to generate in the drawing space a whole floor 2 for us here. And we can follow the process here below. It's finished in just very, very nearly finished. A couple seconds, I think. And then as it finishes, of course, we want to check if it looks like the course material again, or at least somewhat close to it. But it looks like it does here, of course. Looks great. So, modifying elements of the second floor. Select all the sandwich walls and press the command Edit Wall. Change the bottom and the top end caps from none to WD34832 and WD34852 correspondingly. Press OK and update all and exit and save. We're just going to move it here. Select all of the sandwich walls. We're going to hit Edit. Select all. We can just do it like this as earlier. Sandwich walls, properties, Endcaps. At the top, we want 832. And at the bottom, we want 852. There we go. And we'll hit OK. Update all. And now, as you can see, it's working its way through all of the sandwich panels, turning the color into yellow as it actually changes the top and the bottom details of the walls, or end caps as we call it in Impact. After we finish that one, we want to end it with the exit and save command. So let's let it run through here. Now it's almost finished, so we're getting ready to do it. Here we go. And then exit and save. And then we're going to give it a couple of seconds to save. We want all elements to keep their element mark. Yes. So giving it a couple of seconds to do that. In the meantime, we'll move forward in the course, and it actually says do the same for all of the solid walls, but instead use the Endcap VD20809 for bottom and VD20810 for the top. Let's go in and go to our drawing. Hasn't completely finished yet. We're saving and editing a lot of stuff at the same time, so we'll let the software work here. Oh, here we go already. Select everything, and then the solid walls instead this time. Properties, top, .8010 should be the top. 809 should be the bottom. There we go. And hit OK. Update all. They turn yellow just as the sandwich panels. It's quite a lot faster now since we don't have as many and it's only solid walls. Please just save them. Keep all the element marks. So now we're ready to start copying floors again. Copy floor 2 to floor 3. Use the command copy elements and element marks. First, we're just going to go in here, check all the changes are done. Yes, they are. We're going to go to our model view here. We're going to copy elements and marks to floor 3, raise by 100. I'm just going to double check that's what we wanted to do. And copy. duplicate to floor 4 as well. And if we want to, we can do only sandwich walls on the 4th floor and change the top end cap if we want to. So I'm going to go in here, press copy. That's fine. We'll let it copy again all the way from floor 2 to floor 3. And then as the last copying exercise, we're going to copy from floor 3 to floor 4. We can copy as soon as the 3D model has finished loading up again here. So you can see the speed for copying the floor is very fast. But of course, our computer needs to reload the 3D model, which takes a few seconds, of course. And we'll go with floor 3. Copy elements and element marks to floor 4, 100. An error has occurred. We'll just double check. We'll just copy elements and element marks to floor 4 with 100. There we go. It was probably a little too fast there. It wasn't completely finished loading it yet. So we'll just do it again. Copying to floor 4. Here we go. And we'll go in here. The practice exercise. Copy floor 3 to floor 4. We did that. Create a floor drawing only for sandwich walls on the 4th floor. We can actually go in and start to do that also. And then change the top end cap of the sandwich walls from WD34 to WD34 833. Well, let's go in and do that then. Let's go back here. It's almost finished reloading our whole building with including floor 4. Here we go. So now we've gotten quite far since we started this training material here. Go to floor plans, make a drawing. Let's call it GAO 104 then. We'll go floor 4. Okay. This time what we want to do is we want to go in and generate again, but we only want to generate the sandwich panels. So we'll go to generate plan, floor 4, element type, sandwich, and hit OK. So the more specific we are, the more specific information we'll get, the faster it'll also be, of course. So now instead of making the whole floor in the drawing, we're just making the sandwich. Again, just for the sake of the exercise. And we're going to change the top end cap of these ones so that it fits with them ending on that 4th floor. So we'll go in here, we'll select all the sandwich panels, we'll edit them, go to properties, Endcaps, and the top end cap should be, which was the top? 833. 833. Great. Okay. Impact will again ask us to update the lifters. We'll update all, and then impact will work its way through again the elements here. And we will hit exit and save. Yes, please let all the elements keep their element marks. Let's go back to the training material. And let it save in the meantime. It's going to finish in a few seconds. So no reason to sitting and look at the screen for that. So basically the next thing is creating shop drawings. So we got that far. We made the whole model. We made the whole building. We made 4 floors. We made stairs. We made balconies. We made slabs. We made double T's. We made walls. We made sandwich walls. We've really done a lot of work in the last few hours. And now in this training material here, finally we have arrived at creating shop drawings, which is one of the most interesting things in Impact, because that's where the magic starts to happen here. You know, when you click a button and suddenly you just get the result. So let's continue with the next chapter, creating shop drawings. So objective of shop drawings, I'm not even going to read that, but that is of course for you to produce your elements. There is an important note though. The seamless connection between the floor elevation plans and shop drawing separates Impact from its competition. Any change in any type of drawing will require press of a button to be updated in all of the other drawings. This is of the utmost importance, as is described in the next chapter also, how to do that. How to correct something from a shop drawing to a model, the other way around. To begin with, we will want to create the shop drawings for our elements. In order to read the shop drawings module, in Impact we'll need to use the command generate shop drawings. The command has the same icon but is different for every element type in the plan module. In the picture below, you can see the location of the command to generate shop drawings for every element type. Open the drawing GA0101, select all of the elements, precast plan, wall, generate shop drawing. Select to only generate the sandwich walls. Then you will get this menu here, which is should the drawing be named the same as the element. And then let's save it. Let's create it. And then Impact will create all of the drawings for all of the sandwich panels. This might take a few minutes, worst case scenario. And that means that that's the time to make a quick cup of coffee. So that's exactly what I'm going to do, but I'm going to pause the video so you're not sitting and looking at it for 2 or 3 minutes. We're talking about a few seconds for each element and it will create the drawings. Note, in Impact, when we generate shop drawings, we're actually creating a lot of different views of our elements. The template in our case is called Sandwich Wall Layout and can be modified to match any company standard. The drawing name can also be changed if you want. The next step will be do the same for wall, Hollowcore, slab, pre-stressed slab, column, and beam elements. Select the elements you want to generate drawings for and press the corresponding Generate Shop Drawings command. If you select all elements in the plan, it should not matter as the software will automatically generate only the shop drawings of the elements that you want. In our example, it could be Hollowcore and double T. Press OK for Hollowcore, press Generate Shop Drawings, and then OK. And then we'll just work our way through the rest of the element types here, as you can see. Then all of the shop drawings are created. Good, that was a lot. So let's go in GA0101, select all of the elements. Wall, generate shop drawings. Sandwich. And now we're creating all of the sandwich wall drawings for the whole floor at once. It's going to take a couple of minutes as mentioned. So we'll just hit OK. And what you need to do now is you simply need to let Impact work. You will know it's finished when you can actually start to zoom in and out of the screen again and use AutoCAD again. Don't worry, it's not stuck. If you do 100 drawings at once, it's going to take a little bit longer. If you do 25, it's going to take not so long, and so on and so forth. So for the sandwich walls, these are the ones we have the most of. These are the most complex one. It's the one which creates the most material, so give it a couple minutes. Great, so it finished here. So we're going to do the same thing for all the element types. So Now I hit save instead to begin with, and it asks, okay, what do you want to do? Well, then we can go with a selection. I'll do all of the solid walls. It's going to ask us again, sandwich or solid. We're going to go with solid walls. I hit save. I did not hit create drawing. So there we go. We'll create shop drawing for solid walls. Wall here. It's not that many, so it's not going to take that long. You're going to go again ahead. And then again, of course, give it a minute or two. It's not going to take as long as it did with the sandwich walls. And once the walls are done, we're going to move on to columns, beams, slabs, and so on. Now the wall's finished. So we're going to generate slabs. Select everything again. That should mean that we could do the slabs, the balconies, and the small slabs in this case here. And as well as the slabs that we made when we was making the linked elements also. So here we hit OK again, and the same thing. Let it work through it. Then we'll do slabs again. Generate shop drawing. Maybe all the Hollowcores and double T's now. Here we go. Those finished as well. Let's go with the last of our slabs, which is the oh, that was save again. We want to generate shop drawings, which are the pre-stressed slabs. And then all we have left are the columns and beams, of course, which there aren't too many of, not the pre-stressed slabs either. So for the pre-stressed slabs here, it's going to be a little bit quicker than what you've seen before. Simply because it's fewer elements to create the drawings from. In this case here we have 6 slabs that we're going to create drawings for. And for the columns and beams, of course, we will have 4 columns and 2 beams. It is already finished while I was talking as well. So let's just go ahead and take the beams. And in the case of the beams, you can see it was only one drawing actually, because the beams are identical. So it's going to make one drawing type for those, of course. And then the last thing we're going to do is the columns. And then, oh, sorry. It may be easy to select them like this, the columns. And then we've actually drawn all of our elements. Columns are the same as well. We've drawn all of our elements. And made shop drawings of the whole thing as well. So perfect. So now that that is done, in order to access the elements, we'll need to use the command open shop drawings, which is located separate for every element as shown in the picture below. This is where it's located. Select one of the sandwich walls, preferably wall 117 in the bottom right corner. That might not be called 117 for us. It does not matter, it says. Then use the Open Shop Drawing button, and it will navigate you to a sheet in CAD with the name of the drawing and a completely new format waiting for you there. Great. Let's do that. In this case, ours is called 110, but we're going to open it. Open Shop Drawing. Select the element, hit enter. And now, this is some nice stuff. Now we're being taken into drawings that look really good. We have all the components, we have all the things in. There's even some reinforcement done already and things like this. Really nice. But that's not the drawing itself, is it? Well, not really, because there are layouts as well. But let's not get ahead of ourselves compared to the training material. So, reviewing, understanding, and finalizing shop drawings in Impact for CAD. So I'm just going to read this here because it introduces us to this new module. So as you might have noticed, when opening the shop drawing, the header tab moves from plan to the one called element. This means that when working on shop drawings, the element tab is the one that is active and can be used. This is something that we encountered using the elevation module in the earlier stages of our training. The following picture shows the element tab. Reviewing the shop drawing. There are three views in our sandwich wall drawing, which can be found at the bottom of our sheet. The model layout. This is where we can modify and reinforce our walls or add more reinforcement to walls. We can edit every detail and add extra views for elements. This is where the final views used on our other layouts are being taken from. The element layout. This is the final drawing that we'll print and submit for review. This drawing concerns the geometry of our element. It consists of many viewports, as well as the drawing head and details taken directly from the model view, and therefore there is no need to edit anything regarding the element in this view. All viewports are set in the shop drawing template beforehand. Then there is also the reinforcement view, which is the final drawing that we'll plot, print, and submit for review that concerns the reinforcement of our element. It consists of many viewports as well as the drawing heads and details taken directly from the model view. And therefore, there's no need to edit anything regarding the element in this view. All viewports are set in the shop drawing template beforehand. Very important note. In most cases, the element and the reinforcement view are combined in one view called the layout. For sandwich walls, due to the complexity and many geometrical views, it's more difficult to find in one layout sheet. So sometimes you'll have two sheets, sometimes you'll have three sheets, if that's the way you prefer detailing sandwich walls. Then it can be done. You set up your own standard, 2, 3, 4 sheets even per element, no problem. Reviewing the model view, we can see that we have a 2D plan view of our elements, which we can use to verify all different features are accurately represented, such as dimensions, placement of reinforcement and casting materials, check for alignment with the floor plan, confirm that the element's dimensions and features matches the plan. We also have vertical and horizontal sections, where we can see the side sections with the reinforcement and the custom materials, or without it even. You can create as many sections as you want. We also have two reinforcement views that we use to draw reinforcement in. We also have views for the Endcaps, which are the details. We even have a 3D view, which I don't know if configured is already there in the drawing. Oh, it is right there. So the reinforcement views, inner panel, outer panel, the elevation view, section, Endcaps. If we go to 3D, we'll have a 3D view in this case right now without reinforcement. We can also add that. Drawing head and many dynamic information tables regarding casting material and reinforcement. Dynamic means that every time you add a new reinforcement or casting item in your element, the table will automatically be updated. So we'll just go in, I can go in and look at it for you here. So if you go in here, basically it says what is the area of the element, what is the mass, volume, how much insulation, what is the name, what about the project information, and so on and so forth. And we can go into our main, which will show us this layout here. We can go into our reinforcement, which will show us the reinforcement layout. And there are different settings of getting this to look exactly like you want it to look, of course. So connectivity between shop drawings and floor plans or elevation plans. There is a dynamic link between shop drawings and floor plans. Any shop drawing changes will update the corresponding floor elevation plan with the press of a button. An example could be If an opening is added to a wall in the shop drawing, it will appear on the floor elevation plan with the press of a button. In this chapter, we will explain this procedure thoroughly. It is the most important procedure that a precast detailer needs to understand in order to be able to work properly with impact. There are two ways of working: editing or modifying an element on the shop drawing and then updating the floor or elevation plan, or editing the details in the floor plan and then updating the shop drawing. So we're going to go through method 1 first. Synchronizing changes from the shop drawing to the floor or elevation plan. Open the drawing as we did before. Let us make a change in the drawing. In this case, we will draw panel ties. So go to the panel tie command, fill out the properties as shown in the picture below and press OK. I'm just going to move this to the side so I can actually see it at the same time. And then I'm going in and I'm going to go to Wall, Draw Panel Ties. A150, B300. The group should be Panel Connectors 781. D should be 400. E should be 200. We don't want to double around the openings. We want the offset to be 200 as well. And then here, give it a couple seconds to actually be able to draw everything into the element here. If it takes a little bit of extra time, don't worry. Just as with saving the elements, let the software work. The more it does, the more it's going to take. The more you've been working, the more it's going to take. The worse your internet speed, the slower it's going to be, and so on and so forth. Redraw the element. We're going to select no in this case. And then we'll go back here and we can see now the changes have been applied to the wall but are not saved yet. To save the changes to the wall, we'll need to use the MTO commands. The commands will be explained below. In our case, we will use MTO all materials. Answer yes to redraw the element. Answer yes to redraw RC views. And answer no to the third question that we don't want to update the lifters. Once we've done this, we should be able to see these new panel connectors in the list of cast-in materials as well, and we'll be able to update the floor plan with that element information also. So first we'll do this and then we'll go to the floor plan to update it. So MTO means save into impact all materials. So that's the first thing we'll do. Click that one up there. Redraw element, yes. Redraw reinforcement views, yes. Update list and bracings, no. Great, that's what we wanted it to do. So let's just let it do it and finish the saving command here. While it's doing that, we'll slowly creep ourselves into the floor plan GA0101. And then in there, we need to use the command update plan, which is located under plan and update plan. We used that once before, if you remember that, when we moved the linked stairs element. So we'll go in here to our plan and update plan. And then it will say you've done a change in SW110. Click update for updating. That's fine. We'll do that. Or check update for updating, sorry. Now the wall is updated on the floor plan also. Note, there are many MTO commands, each specific to save different changes. The different commands are MTO all materials and redraw element, no questions asked. That's the A with the fast forward sign on it. All materials is the A. Only cast in items and geometry, this logo here. Only cast in items, this logo. Only geometry, this one. Only reinforcement. And only specific symbols that were changed as well. So the reason why you would use some of these is that it's faster. The less you do, the faster it is. So now we can go in to the floor plan and edit the bottom end cap for the wall. So we'll go into the floor plan, we'll use the command edit wall, properties, change the bottom end cap to none, and then press OK. Then we'll press yes to update the lift and bracing anchors. We'll hit exit and save, and we'll press yes on keeping the element mark as well. Then after that, we'll go to the shop drawing, and we will actually regenerate the shop drawing, which will make it call for the information from the floor plan we just changed. So we'll go into the floor plan, we'll select the element, we will edit the element, properties, Endcaps bottom, none, OK, update, placing a lift and bracing anchor, yes, exit and save, use existing mark, yes. Then we'll go to our shop drawing, and then we'll use this command here, regen. So the difference is we can see at the bottom WD34830 under the section here. If I then redraw the element, and let's just see how much do we want to redraw. Press no to the third question asked about the lifters, but yes for the rest. Now your shop drawing is updated with the latest changes that was made in the floor plan. Review the updated shop drawing to ensure all changes are actually reflected. Important note, in a special case where you've changed multiple elements on the floor plan and you do not want to open every drawing affected one by one, then you can draw element. And then you can select all the affected elements and press generate shop drawings again. In a case like that, you will get the following window. You need to fill out the X boxes for all the drawings. Use the marking options at the bottom of the window for faster markings. Okay, so that will do. Redraw reinforcement views, yes. Update lifts and bracings, no. So now let's let the drawing update itself here, or the element update itself from the actual floor plan here. And we've actually, if you were very fast, you could see the changes. The end cap disappeared from the bottom over here. That's the actual change that we did. So now there's no named end cap on this one. Summary of commands. Method 1, updating the floor elevation plan from the shop drawing. Modify the shop drawing, do the MTO, and then update the plan. Method 2, modify the floor or elevation plan. Exit and save or resave the element. Open the shop drawing, draw the element. Or, if you're editing multiple elements on the floor plan, modify floor plan, exit and save or resave the elements, generate the shop drawings again. Important note here. The software will not allow you to edit elements on floor and elevation plans if they are not updated. You will get a warning. Tips for success, especially in your early days with Impact: periodically update floor plans, elevations to avoid misalignment with shop drawings. Drawings that are not updated will get a warning message when you open them. You can see below, elements that are not updated. Drawings that are not updated will also get a bold name in the project manager as shown in the picture below. Always verify changes in the floor plan are synced with shop drawings before sending them to production. Use consistent naming and labeling for elements to avoid confusion. Regularly back up both floor plans and shop drawings to maintain a history of revisions. That's it. Now we've made the shop drawings, we've opened them. You can go ahead and open up any other shop drawing to review, to change, to try it out in here in the software. We've made shop drawings of it all, so just go ahead. We are almost at the end now, but we're still missing to draw some extra reinforcement, like some manual extra reinforcement on the walls. That's where we're going to use the exercise there. So let's jump to that one now. Now we are in the final chapter of this impact beginners course or impact trials course or whatever we want to call it. And that is draw reinforcement on wall and export formats. So a little bit information about exporting and so on, and a lot about information about how to actually draw custom reinforcement. So in this final chapter, we'll be looking into and investigating the following topics. Review a reinforcement template made for a sandwich wall. We'll draw bundle reinforcement, draw wall beam or column, or wall column reinforcement. We'll convert bundle reinforcement to reinforcement groups. We will draw bars and bar marks, and we will export reinforcement to machine file formats. So adding reinforcement to our elements is one of the most important skills to have when it comes to finalizing the shop drawings. The following chapters will address some of the most common impact functionalities. This is basic knowledge training and not advanced, remember that. So if you need advanced training, you probably need to get a hold of somebody from Strusoft to give you the training. So we're starting with this one. Review the reinforcement template for sandwich walls. We'll import an existing reinforcement template into our project and review its properties. No need to make any changes. Open the floor plan drawing GA0101 if it's not already open. Find and use the command reinforcement templates and select your project level. Press import export. Select the standard template WA001 and import it into your project. Press OK. Note, if there are templates with the same name on both the project level and the common level, the rule is that the project level template will override the common level. That is applied to all element definitions, sim, casting material, joints, endcaps, and casting material templates. Select the template from your project file and edit. Okay, we'll just do that and then we'll go back to here again. 0101. We'll go to reinforcement under components. And I'm just going to show you a little bit slower. Components, reinforcement templates, import export, WA001, import to a sandwich. There we have it. We'll hit OK. And then hit edit. Now it's opening it up with a brand new window with a lot of information in it. Let's go back to the training. There are 6 different types of standard reinforcement for sandwich walls. One is called bar mesh, is for welded mesh. The types are double mesh plus double rebar. That's the one we're going to use. Single mesh plus double rebar, single mesh plus single rebar. After choosing the type, it's possible to select the placement of bars and mesh. So like covers and so on, everything's explained on the picture. Double mesh and double rebar looks like this. Single mesh and double rebar looks like that. We can adjust the cover for the reinforcement and the placement. Just keep the values. The measurement for cut means the cover of concrete in the reinforcement length direction. The measurement placement is the cover concrete that the edge for the bar belongs to. This will affect the placement of the bar. Edge reinforcement, it will apply straight bars at the edge of your sandwich wall or solid wall. If you don't want any bars, insert 0 in the quantities box for those sides. You can also have more bending types as shown in the window below the dimensions. The end cap reinforcement is a more advanced feature. We will not explain it in this training. Corner reinforcement. Different types of corner reinforcement. We'll just leave it at 0 for the purpose of this training. Opening reinforcement, predefined reinforcement around openings. Select 1 out of 3 measure types. This figure here shows anchored length and 350 millimeters. The end cap RC will just leave at 0. Select the mesh type for the inner and the outer panels, N6150, N6150, N5200. So if we go in here, we can see if we change different things. It's going to change the picture here. Edge reinforcement, corner reinforcement, opening reinforcement, just as we get with these. Mesh, as we came to that one as well. And then wall beam RC and wall column RC are predefined reinforcement shape codes with a set of dimensions and cover from the concrete edge that will be used alongside impact to efficiently draw reinforcement within the corresponding wall. In the following chapter, we will use this information to draw a wall reinforcement column and beam. For now, fill in the information as shown in the two pictures below. So we actually need to do something here. Or maybe if it's not filled out already. N 10. I'm going to take this one and move it to the other side so I can just fill it out. The quantity should be 3. And for the wall column, I'm going to go with N8. Quantity to be 3. And then press OK and OK because now we've made some changes. So now we're going to draw some reinforcement. Draw wall, beam, and wall column reinforcement. The reinforcement proposal adds reinforcement around openings, edges of elements, and mesh, but it does not take into account the engineering calculations, of course. The building structure requirements need to be addressed in an appropriate manner, and therefore extra reinforcement is required in this case. Open drawing SW117, which from earlier in our case was SW110, which is the corresponding wall from our project. Then use the command draw wall again. Answer yes to both questions. We want the RC views to be redrawn. So let's go in and do that. So here we have them. We'll go in here and we'll see reinforcement inner panel. Firstly, we'll draw an RC column between the door and the window for the inner panel. Find and use the command element reinforcement draw reinforcement column. Software will ask you to select the left edge of the panel thickening. Press the left side of the dotted line. The software will ask you to select the right edge. Press the right edge of the dotted line. Next, you'll need to specify the first extension line origin. Select the top dotted line. Next, you will need to specify the second extension line origin. Select the bottom dotted line around the window. You will need to press element on the following question. Lastly, you will need to specify the distribution line location anywhere in between the right and left sides you selected before. Then the following window should pop up. It will have the same dimensions as the one we set inside our reinforcement template. Press OK. The result should look like the following. Good. Let's try and do that in one go, if we can do it correctly. I'm going to zoom into here. In the inner panel, which in this case do not have the dotted lines around the window here. No matter, it's not important in this specific thing here because the important thing is to draw it. So we might have updated the software in the meantime and it might look, some things look a little differently. But first of all, we're going to draw this one, the reinforcement column. Select the left edge select the right edge, specify the first extension line origin, second extension line origin, element, distribution line here. Comes up with this one. Shouldn't do any changes, so we'll simply hit OK. And it should look somewhat like the following, which looks exactly like the example. Now we want to set a bar mark to a stirrup. So select the stirrup and double click it. The following window will pop up. Give it the name 1001 and press OK. Let's do that then. 1001 and OK. There we go. The name is now changed to the following. Naming your bars is something that we create in your own standard. If you name your bars in a completely different way, then no worries, as everything is easily modifiable in Impact. Now we want to save the reinforcement in the element. You need to press Ctrl S if you want to save your drawing. But we can just do that, of course. Set Ctrl S. But the process for saving the reinforcement is to hit the MTO reinforcement that we learned about before. So let's go in and do that. After we do that, the RC will now be saved in the database, but not drawn in the sections. We did not use any MTO that redraws in the sections. That is why if we want to be able to see the RC in the sections, we need to press on the command Draw Template Proposal. 3 questions will be asked. Say yes to the first 2 and no to the last one. The result will be the following. Have it in your sections. The description of the bars can be modified in your standard. Great. Okay, so let's go back to this one then. Let's run the MTO command for reinforcement. And then once we've run that, let's go in and run the command for redrawing the reinforcement in the sections. Or was it Draw Template Proposal? There we go. That's the name of it. And after that's done, we can zoom out a little bit from this view and check our sections to, do they look correct? We have everything. There we go now. It's drawn in our section as well. We add a little bit of custom reinforcement to this one now. Let's continue. The next step is convert the wall column into a reinforcement group. Group in Impact is a combination of stirrups and straight bars that are handled as one item and not as separate single bars and single stirrups. The group will get a name and then can be ordered directly from your providers or created in your own steel factory. This step might not be relevant to you, but it is part of this training as a quick overview of RC groups. Select the bars that were created from the reinforcement column command. Select all of them. Use the command convert to reinforcement group. Press 90 on the rotation. Press MTO RC and then the new RC group is saved in your definition. You'll get a view on the bottom of your model like that. We'll see how it looks. Let's go ahead. Select them. This one. And these ones. And we will convert to a reinforcement group. 90. There's like an arrow on it. And then MTO, reinforcement. Then this one should get a name. And if we zoom out, a detailed drawing should automatically have been created as well. See, this is called A2. Nice little detailed drawing with a section created of this with the names of everything as needed. Start by removing reinforcement from the reinforcement view. Remove the original horizontal bars over the door and the window. Okay. Let's go in and do that. We don't need them since we're making this group here. Delete, delete, delete. There we go. Press the command draw wall beam. Just as we did with the column command, set bottom, top of the door, the top of the wall, left and right edge to the left and right edges of the wall, and finally add the bars in between the space. Make adjustments in the following window to 250 and the quantity to 2. Okay. Let's go ahead and do that first, then we'll go into this one. So we'll draw the beam, bottom edge here, draw the beam. Oh, I'm missing it, sorry. There we go. The top edge, we'll take that here for where the wall starts to act up a little bit. First extension line origin, here, second, here. Straight bars by element, distribution line location should be there. We get this one. And you can see actually it proposes to do 250. In this case here, since we've selected this wall, that's not going to work because it simply won't fit because we made recesses in the top of the element, which is good. So in this case here where we have selected a different one, of course it won't fit for us. So simply go ahead and use that instead. What we're going to do also is we don't want the stirrup to be 70 millimeters. We want it to fit inside the other reinforcement column. So we're going to make it 50 and only 2 rebars as well. We're going to make this one 50 and only 2 rebars. We might make this 160 or 150 if it's different. Then we'll hit OK, and we should have a fine result looking somewhat like this. And we'll have that right here. These ones we can delete because they're from the old reinforcement we deleted. If you made a mistake or didn't snap correctly, delete the bars, do it again until you reach the result above. So basically for us, it was 160 mil, not 200 mil. Set the ball mark of the stirrup, just as we did before, to 1002. Double click it. 1002. Select OK. Perform MTO RC and then redraw template proposal to receive the following result. To achieve, sorry, not receive, the following result. So that we're going to do the MTO. And after the MTO, we're going to redraw the template proposal, of course. So when we do the MTO, just as before in the earlier exercises, all the amounts and everything gets updated. We'll say yes, yes. No point in updating lift and bracing since we haven't changed anything really. And we will hit this one here, redraw the template proposal. And then how should it look? It should look somewhat like this. This is where one section is. This is if it would be 250. We're not going to do that because we actually had the recesses from the actual slab laying above it. So we have a lot less space here on working on. There we go. When we actually redraw the template proposal, what happens is that the bars on top of the door come back. So you can see this comes back. We don't need it. We don't need this one either. And this one. There we go. Now let's look. All good. As you can see here, if we're using these, we get a little bit of an issue with the actual size here of the beam. But we're following the training material completely through. They might be a little bit small. We might go in and we might change the end hooks. You can see from the front here. We can change the end hooks to none and none. Or we can have them to 135. But since it's only 50 mil, we need to make it smaller to even fit in there. So we can also make it smaller to 6 mil, get it to fit, override the existing bar mark. Now let's just get it to rotate correctly. So even with some small mistakes in some of the training material, which might be corrected by the time you see this, we can easily go in and edit this. That's the whole point. Nobody's perfect. Neither will you be when you start working with impact. You can even see in the training material here that the actual end is going a little bit outside the element here. So, and of course, once we finish that, what we want to do is we want to go in and want to MTO our reinforcement. And we get these questions again to update the element and so on. So in general, with this MTO, you don't have to click it until you completely finish working with the reinforcement. There's nothing that says you have to do it all the time. You just basically have to do it before you close the drawing or before you finish working in this. So we come to this draw other reinforcement. This is basically any type of loose reinforcement, or even if you want to create different reinforcement columns, beams, and so on, custom ones, then you can use a combination of these tools. Again, that will be under advanced, but in the simple one here, we'll just show how it actually works. So we'll draw some serifs in the corners. There's even an automatic function for this, but it's a good exercise anyways. Use the command draw a bar. Under general, adjust the following information. So we're going to do that. I'm just going to go in here. I'm going to go with draw bar. I'm going to go with 1003, 350, 350, shape code B, 10. Oh, when selecting the shape code, it resets this one. 350, 350. And then we want this one to be turned like this here. Check the representation tab and add -30 and -30 for dx and dy, as well as the insertion point 2. This is so we'll make it easier to inset the stirrup with the correct cover of concrete here. Let's go to representation, select 2, -30, -30. Then we'll have the insertion point right here. Go to the number of bars, change the number of bars to 1. Go to the text, keep it at the ES European standard, then hit OK. Number of bars, 1. It might be up here, put it down here. Text, ES, hit OK. Override existing bar mark. You will probably not get it, depending if you made a name already of it. You need to be sure you're not breaking anything. We'll put that, and instead of actually the cover, I don't want that here in my case. I want it to be on the inside of the other reinforcement. And I'm just going to make this one maybe like this angle. Then we inserted it. Now we can insert it 3 more times, rotating it for the rest of the corners, but we can also use the CAD commands such as copy and mirror. So I'll try that. I'll go in and I'll just take this one and mirror it. MI for mirror in AutoCAD. Any point in this case, I don't want to erase the source object. I'm going to move it to where I want it, which is here. I'm going to take both of these and mirror them. Don't erase the source object. And we're going to take these and we're going to move them down just a tiny bit. Perfect. That's how I wanted it. We need to do an MTO for the changes to be applied, and once it's done, you can look to your schedules if it's applied. We will do that as well. We'll go ahead here and we'll run the MTO command. Now we've added a little bit more reinforcement outside of the element. And you can just continue working like this. It's very simple to add reinforcement and impact. There are collision controls. There's 3D reinforcement. You can see the representation as well. This is just all very, very basic, just to get you to try it out. Export data to machine file format. So, exporting files to your P systems, machines, and so on is essential, of course, for your production workflows. Common formats include Unitechnique, PXML, BVBS. In Impact, it's easy to export and send it directly to the folders that your machine is reading. It's a procedure that happens either from the Impact CAD software or directly from the project manager. Typically, we would want you to do everything directly from the project manager, because it will then be irrelevant if the files are created in Impact for CAD or Impact for Revit, and so on and so forth. BricsCAD or AutoCAD, all these things. It wouldn't matter if you do it in the project manager. You will be able to find all the supported formats under the export function in the project manager. So there's both exports for machines, but also exports for different ERP software. And you can also connect Impact with an API, of course. There are even settings. This is like on top of this one, of course. There are even settings for automatically getting the reinforcement exported into different formats as well. If you go to exports, well, you'll see there's a bunch of exports here. The standard training does not cover specific exports, and neither does the trial software, of course. But for your business, when you're using Impact, this will be covered together with TrueSoft. So in conclusion here, the reinforcement module has a lot more functions that can be used as standalone on drawings that have not been produced with Impact. Basically, you can actually use Impact RC to reinforce cast on site concrete as well. For a more detailed presentation, demo, training as well, you'll need to contact one of our guys here at TrueSoft or find more info on our YouTube channel. This was actually the last part of the main training. So the last recommended thing is to move on to the summary exercise before actually ending the training. We'll click the summary exercise here. And this one here, you guys need to be challenged a little bit. So I will not be going through this with you because there's no point in you doing also the workflow exercise here by just following along on a video. This will tell you what to do. Applying all features from the training. Detailing a precast floor for a 3-story residential commercial building. So that's the job. You will have your external references, you will have your links to what you need, and basically follow through. This is the same as the previous training, but it is just saying, for example, let's give the example of slabs. Draw the different types of slabs as you see fit. Try and play around with the different span and support lengths. Rotate the slabs before creating them. If you forget how to do these things, go back to the piece of slab training and go through that. So it's very simple. But basically that's it. So congratulations. Thanks for your effort. You reached this point. You've done an extraordinary job. You've completed the basics of the introduction to impact. You should understand what impact is and what it can do now. So there's nothing else to do than go back to the table of contents and then just pat yourself on the shoulder and say, job well done. That's it for me here in this video as well. And we'll probably see you in one of the next ones. Thanks and bye.